Hello. How you doing? Welcome, welcome. All right. Hey, going to House. Welcome, welcome. So, yeah, I'm going to continue today with this MFM encoding stuff. See if I can make, I don't know, heads or tails of it? Not heads or tails. See if I can make better sense of it and continue onwards. Yeah. So the last time we were here, we got the peak detection working. Where the hell was that? I jumped around. All right, yeah, the peak detection working right here. So we can see when a peak happens. Yeah. And in theory, from that, we should be able to figure out, Bridgewater, how you doing? The rest of everything else that we need. Maybe? I don't know. I did do a little bit more reading on MFM today. Was it today? Yeah, I think it was today. Having lunch, nice. I just finished a little while ago. Yeah, so we'll see if I can figure out how to implement this stuff correctly, or at all. I kind of get it, but yeah. So I don't know. We'll see. We'll see. I'll probably start with just mimicking how Sour does it here, at least at the beginning. Yeah. Let's see. Yeah. And then we can go figure out like adaptive clock cycle stuff. Or not adapt. Is that the right word? Basically, getting the clock cycle off of the clock timing off of the actual audio track instead of having hard-coded numbers. So we would be stuck using just 44.1 kilohertz audio in. We could have any what's it? Recording frequency coming in. I mean that'll still be a little bit of a problem with the recorded audio because again I don't think Messin can do anything. Let me actually check that. Can Messin do anything other than 44.1 for the playback audio? GitHub. No, GitHub. Sour. Messin 2. Where would this be? Core, maybe in the core. Ness. Mappers is a studybox.h. Does this have the implementation in it too? Yes, looks like it has some implementation stuff in it too. Mapper, serialize, yeah, okay, process, CPU clock, sure. Read register, tape status stuff, write register. Where's the audio stuff? You can either try to automatically detect the speed from the inner peak distance, or you can calculate the expected inner peak distance ranges from the declared sample rate. Yeah, I'll probably start with the second one, getting the sample rate, and then saying, oh, it should be this. See where that gets us. But I want to get it like I'll hard code shit at first, and then I'll work backwards from there. Yeah. Playing around with FM2, writing some code of my own to see if I can figure it out. I haven't really gotten any further than you're at. The edge times and measure of the distance between each bit. Well, this isn't necessarily each bit. It's each peak, and between the peaks can be what, up to 3 bits or something, right? 3 or 4 bits. No. So depending on how long the distance is between those two peaks, how long the time is between those two peaks. Why is this scrolling correctly? What the heck? Okay. My teleprompter wasn't scrolling all the way. Yeah, depending on the timing between the stuff. So, yeah, I'll come back to that in a minute. Yeah, so audio provider. Okay. What does audio provider mean? Audio sample rate. It has a fixed sample rate. Okay. Right there. Yeah. That can't be well, let's see. Is this used in Huh? No. What? Copy. Paste. How dare you? Unsupported file format. Yeah. Okay. Yeah, so it only accepts wave at 44.1. Which is unfortunate. Wave reader, where is this? Search this symbol. Audio, wave reader. Okay. The audio, what other audio stuff you got here? Just wave stuff. All right. Just wave stuff. Play, start sample, is playback over, apply samples, get position, get sample rate. Okay, so the engine itself, allegedly, supports more sample rates. Right? Start sample, file offset, stereo, what the hell? Data offset plus start sample times 2. Huh. Interesting. That's what I mean. I think we decided at the end of the last stream, using peaks or edges really doesn't matter. It's the time between them that matters. Right. So my code turns the samples into edges, like you do peaks. Okay. And then he uses leading to figure out the time in samples for each bit. No, for each cycle then, yeah? All right. Yeah. Resampler. It resamples it. File sample rate, sample rate. What? Stereo samples. Okay, yeah. Get position, get sample rate. Huh. Right over here. Sure. Where the hell was mix audio? Override. Out. Sample count. Sample rate. Huh. Where's the other audio stuff? The leader is a plain cycle until the end of it at least. So the distance between the peaks or edges and the distance to bits. Right. Yeah, in the stuff that I have, that's either 9 or 10. Oops. Can I scroll here? Oh, I can. Nice. Yeah, so it's either 9 or 10. Yeah. There's a serialize. Oh, is that for what's it? Save states, maybe? From about 40% through my file of ramblings in code, which I was figuring out the encoding in the first place, it's starting to look like we might be looking at low-passed square waves for data regions and lead and tone. 9 point something, so you just see it as 9, but sometimes it ends up as 10. I mean, it varies a little bit with that. 1, 2, 3, 4, and then 3, and then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I don't know. Followed soon after by... Anyway, the new detection plan is to pick out the sign bid from the wave samples, count runs, report them, and see if we can spot patterns in the result. Where did I see the... This? Okay, Control C. F. Yeah, that works. It's in the init. Okay. Why did I scroll right over that like 3 times? I wonder if this loads it all into memory, or if it reads it off disk. Yeah. Anyway, I don't need to get too deep into that, because it told me what I want, what I need to know. The audio sampling rate is fixed for the recorded audio, which is unfortunate, but whatever. Okay, so no, stop that. I don't stop that. So, fun. So how does he? All right. Up here, time gap. Large gap is detected. Write current data to disk and start a new page. 7K link seems a little high, but I mean, time gap. So, wait. What if the gap is between 1,000 and 70,000? What happens then? Because it'll fall into this here. Last but else. Huh. Did it change the sample rate if it had a wave reader, or was that for non-study box? Study box just always sets it to the same sample rate. It doesn't read the sample rate off of the I closed it off the file. So this is the generic, or the audio stuff here, which does handle apparently sample rate. It's passed around a bunch. Sample rate offset, samples needed. Yeah. It's just that it's hard coded in the study box stuff, in the study box specific stuff. So whenever it gets anything from the study box, it goes, oh yeah, this is totally 44.1 kilohertz. Yeah. Anyway, time gap. Just in a mapper or something routine will change it sometimes. Well, yeah, it's passed into the initialization. Yeah, audio sample rate. Wherever to play, somewhere in here it is. I think I saw it, but no, audio sample rate's used right there. Read lead-in track. We have to take to read through the lead-in before the actual data. Why does it have to do that here? We're picking up what appear to be 3 different clusters of cycle lengths. The lead-in tone is all 8 and 9. Some 7s occur elsewhere. Some areas are 12 and 13 with a few 14s as outliers. Some areas are 17 and 18 with a few 16s as outliers. There are no 6, 10, 11, 15, or 19s. Well, I mean, I found some 10s. I've got a bunch of 10s. Line 112. 12. No. What? 122. Sorry, I misread that. Does it crap out if it doesn't if it's not that sample rate? Create. Length was 100. Basic wave file. Read checks. Yeah. Okay. Riff 4 wave and format. Sure. All right. But sure. Channel count. Only mono files are supported at the moment. Okay. Wave data. Data. I couldn't find check. Okay. Data chunk too big. Okay. Bits per sample only support 16 bits bit samples for now. Sure. Sample rate. Wait, it gets it out. Hang on. Wait a minute. No, it gets it out of the actual file. So I, in theory, could use a higher sample rate for the audio playback. This is the audio recording I was using. Also, note the tape stretch will drop the frequency of the tape of the waveforms. Yeah, lengthen. Right. All right. It looks like you tried to read the wave from the wave data from the file. If that fails, the sample rate as a fallback. Yeah. Yeah. Yeah, that could be it then. We'll have to test that out. After we get everything else working, obviously. All right. So, first thing we want to do is we want to chop out that crap because we don't care about any of that. Because that's all the dead air. So if sample delta is greater than 1,000. Continue. I don't care. I'm not doing anything with that. That's this crap here. I don't know why it has to apply a filter for saving the page here. What does save page actually do? Hang on. Save page. Path.get file name with that extension. Oh, I hate it. Oh, I hate it so much. Page. Wait, what the hell is this for? Invalid header. Bad date. All right. Sure, I guess. Puts the actual errors in the file name. All right. Jamaica, how you doing? Welcome. I'll want to have a proper log file, I think, for this instead. You know what? Let's get that set up too. Let's get a log file set up. Log io.writer. Log file. Create. Debug.log for now. We'll name that something better later. What? Paste. What the hell? Did I not? I didn't grab the whole thing. Okay, there it goes. Defer log file.close. L equals log dot new logger. Do one of these. Hey, no, Joe Mega. Guess this weekend the voices didn't win. The voices? What were the voices telling you? New. Okay, logger.new. Log.new. Excuse me. The writer, the prefix, and the flag. Writer is going to be log file. You know, we'll io dot multi writer. The log file and os dot standard out. Like that. Prefix is going to be nothing, and the flag. Let's just give it the standard flags. It's fine. Data and L. Log io dot writer. Log is log. You play Shapes 2 voice. So I started playing the higher difficulty. Was it insane mode or whatever? It's just a pain in the ass is what it is. It's not difficult. It's just more time consuming. Honestly, that's what it boils. That's just more time consuming. I'm only on what is it? Operator level. I think I'm at like 12 now. But I'm already at like top 45%. It's like that's too soon for that, but okay. Anyway, all right. So, I want like a data started kind of thing, right? Or a page found or something like that. Page found. False. Oops. If not page found, data L dot print F. Found page at there. Haven't played in a bit because Star Wars Outlaws, which I did finish this week, and I enjoyed it. Nice. Nice. Yeah, this coming week, I think, doesn't the new Satisfactory update drop? I might have to switch over to that. Get some of that out of the way. Cause that's another dangerous game. That's the next update on that one's coming out. Still some time though until the 21st of next month. Right? A little over a month for that. Okay. Does that work? No. Go my nope. Undefined log. Okay, that helps if I import shit. Log and IO. Cannot use type logger as writer. What do you mean? Loggers are right. Well, No, not as a writer. No, I need to actually use that as a log so I can use the other functions on it. Where is it? Monk.logger. There it goes. That should be better. Can I use L as type logger as long as... Huh? Oh, because... Read done, yep. Found page at... Found a single page. Because I don't reset that ever. Page found equals false. To do write out page, previous page. Okay. That's good. It's finding that. And how many pages does it find? A few of them. That seems like too many. Seems like way too many. Page ID 0. Found page %03D at that. Page ID. I think it's a full tape. Yeah, this is a full tape, I think. Yep, the English one. This is the full thing then. $60 pages. 60 is a little long. There are those anonymous pages where the tapes. That's true too. Right, because okay, yeah, page is used in two separate places that aren't analogous. Analogous? Analogous. Yeah. There's the page designation in the manuals, right? Which is what you select off of the tape, off of the main screen here, which are these numbers here. But that's not the chunks, the page chunks in the actual data. Because there's a bunch of chunks that will be like, what? This is a script one. This one's some character ROM, more character ROM, more data, more script rather, that kind of stuff. Those are the pages with the full headers. Okay, yeah. So let's make that 5,000. See how many pages I get then. Still about the same. I got like 60 something before, right? I got 64 before. Okay. Let's bring it back up to what was it? 7 or 70 that he used? 70,000. Okay. Let's go to 10K first. Sarah was the one to figure out that there's more than the full index headers that we knew about, right? 12. Okay, that seems a lot closer. Oh, this is English 2. Hang on. This is English 2. Let me go to English 1. Get the right number of shit in this one. There we go. Okay. So if it's greater than 10,000, that's the unit header, unit page, right? The tape page. I need a better name for that. What should those be? Should I need a better name for a few things? Should I keep this number that labeled as, should that unit be page? Because that's what the ROM is using. And we should figure out something else for the smaller chunks. Numbered page versus unnumbered page. I don't know. I don't like putting a quantifier on it like that. I don't know. Because this, let's go all the way to the end here. 12. Oh, that'll jump right to the end of that. For data stuff, chunk. That's what I was thinking. Yeah, something like chunk. Right? For the, like the, well, we call them packets. For decoding both numbered and unnumbered pages of the same thing, right? Chunks of data that the ROM happens to use the same to say something is a page or not. I mean, I guess. I mean, so let's go over here. Q new. So a page would be the like the highest kind of level, right? Where there's multiple of these, but the fewest count. Packets feel more network related. I mean, sure, but it's I don't know. But then, okay, so a page can be set up into like multiple chunks. They will have the same page number. And these chunks are like, you know, image or scripts. That crap, right? Packet feels like an even smaller thing to me. Okay, yeah, we'll use chunks. Chunks will work. So yeah, so this is the larger page. I found the workbooks and yeah. Okay. Do I have where is the this command ROM? I named it packets here. Packet header. Packet delay. All right, there's a bunch of different types of these, aren't there? I'll need to figure these out eventually, but not quite yet. New bulk data. Yeah, bulk data, delays. Packet mark data start. Oh, like an address pointer kind of thing. Like the next data will go here kind of thing. Actually, aren't the packets like inside each chunk? Like one solid stream of data and not divided up by a header? Packet header page, another page. I kind of forget how the format actually works. Well, we can. That's a little bit further down the line when we actually have data to work with. All right. Okay, so we're gonna. I don't care about that. Time gap greater than 1,000. Try to find another 0 followed by a 1 sequence. Let's not worry about that yet. Let's actually get the 1s and 0s out of there first. How about that? All right. And I'm alt-tabbing. Last bit. It's nothing. If last bit equals 1, do some stuff. Otherwise, do other stuff. So for now, I'm just gonna copy that in as is, essentially. Else, if sample delta greater than or equal to, right? Less than or equal to 11. First time we split the data into chunks of actual data versus the space between them, then decide the MFM for each of those chunks into binary data. Decoding that data, packet headers, etc., would be a later step. Right. Yeah. Okay, so the first one, add bit. Why do I need the I on that? Why does he have the I on that? Oh, that was just for the log, isn't it? Yeah. Yeah. Do I have let's do this. Type chunk structure raw bytes in a chunk. Current data like that. Func new chunk. Return. Nope. Current is nothing. Data. One of those. Add. Oh, I need to know if I expect 0 or not. Maybe? Counter. Current count. Hang on. Let me get this in. There. I don't have to keep going back and forth. Admit. Okay. So we're gonna ignore the data started for now. Oh, okay. Count equals 8. Why the hell is it already Sunday? We can just started. Sorry. That's what time do. Bit counter minus. See that bit counter minus. See that current or equals byte of. Where the hell did bit come from? Oh, that's the input. Shifted over by see that bit counter. Count. No, what? Count. Okay. If count is 0, see that data equals append data current. See that current equals nothing. Expect 0 true. Is this the only place that expect 0 is actually used? Or, no, it's not. All right, well, we'll pass that in, I guess. And we'll track that above. Oh, shoot. I need God. No, because I need to modify it here. Not just check it. Shit. Don't want to do one of those? That looks disgusting. I hate that already. I gotta do one of those. I equals true. I need to deref it. If expect 0, if bit is 0, bit, no, see that, count, it's I. I'm going to change this to bit. Count equals 8. But 0 equals false. Else. What? If data started and it's 0, it fails. Maybe I shouldn't be. Maybe I shouldn't have a chunk like that, because it's using so much crap from the rest of everything. Yeah. Changing this. Oh, I've already got a current byte. Last bit. Peak the data. Oh, this needs to go over there. Current account. Get rid of that. Get rid of that. Okay. Where's this used? All right, so that's what he uses to retry stuff. I don't like that at all. I mean, wait, what happened? Hang on. Bit counter. What happens if that gets... If that hits 0, and you don't expect 0? Huh? Add D. Get rid of that. I'll probably need more information there, but whatever. It's fine. Yeah, I don't like that. Data last bit equals bit. Yeah. All right. Last bit is 1 time gap. I did it again. Time gap. That's an 11. D dot add a 1. Else, if sample delta less than or equal to 15, you gotta add 2 zeros. Else, add 0, and then data add 1. Zero. What the hell? What is this? Where is this used? Bunch of places. Track lead in and start length. Zero counts nothing. All right. Then in the else, if sample delta is less than or equal to 11, data add a 0. I do need to track the start data stuff. Sleepy Beerb? How you doing? Welcome. This is Go. Welcome. Well, I'm writing Go, but on the right hand side is C#, and I'm basically porting this to Go and figuring out some stuff as I go. So this is code for doing some modified frequency modulation, or decoding it, rather. So I'm figuring out a bunch of that as I read and port code to Go, with the intention of making it a bit more versatile. The original utility that does the thing I'm rewriting was very rigid in the input data, the format and sample frequency and all that kind of stuff. I want to relax those restrictions a little bit, and hopefully in the process make a decoder that recovers a little bit better with data that isn't the greatest, basically. This is all stuff off of physical tape medium, yeah, there's some variance in the data that isn't accounted for in the original code that I want to see if I can account for. But I need to get an A implementation working. So that's what I'm working on. Data started bool. Not that. No. Okay. Yeah, no worries. If not data started. Standard pointer, how you doing? Welcome. D.0 count, add on that. If it's 1, track lead in start and length. Lead in position. Is that the start lead in position? Lead in should be before the data start position. Yeah. Oh, this is the verification for saving out the data. I see. I see. Lead in start. D dot lead in start equals I. So we're gonna save that for later. Used when validating data. Yeah. Okay. Else if sample delta that's equal to 15. Need to add a 1 if not data started. This again. If we didn't start the data, and if d dot 0 count is greater than 10. Why 10? Oh, the number of zeros. It's okay. I see why. Yeah. Because we can't have that many zeros in a row, except during the lead-in. I guess 10 was chosen just to have some leeway. So I think the maximum number of zeros you can have in a row would be would it be 8? Maybe, I don't know. 8 or 9. So yeah, 10 seems good. I'll d to l dot print f here as well. New data track in there. D dot data started equals true. If data start is 0, set it. Data expect 0 true. Current by d dot current equals 0 after 0. Okay. Put those up there. That's really a drink, right? Not at all. Not at all. Left side code feels much cleaner. I'm rewriting it to hopefully be a little bit cleaner. Hopefully. That's not really the main reason I'm porting it over. The main reason I'm porting it over is so I can understand it, number one. Understand how the decoding works. So hopefully we can get an encoder doing the reverse of what these utilities do. Because we don't have a working one of those yet. Bridgewater's done some work on that, and I haven't been able to verify much more of it or try with his encoder again. That was a while ago you did that, right? Like years ago, a while ago. Jeez. Yeah, so I want to be able to... So for a little bit of background of the larger picture surrounding this encoding stuff. This is all for a tape device. Whoop, unplugged that power. This thing right here for the Famicom. So the data is on the tapes. That's what we're trying to decode right now. They are educational type tapes. one of the audio channels is for recorded audio, and the other channel is for data. So we have a bunch that are decoded into ROMs, so they can be played in an emulator. But I like to be able to go the other direction, take the ROM and make an audio file to put it on hardware. So like 4 years before you finally took a look at it. I'm sorry. I'm sorry. But yeah, so I'm trying to have a better understanding of the actual format here. What's the word for it? The audio format? That doesn't sound right. Because it's not really the audio format like MP3 or WAV. It's the audio encoding. That's the word I was looking for. Encoding, the audio encoding. Yeah. And the best way to do that is to write a program to decode it, essentially. All right, else on that. Last d dot last bit 0x00. Yeah. Something just occurred to me. I wrote my code presuming a particular bit rate. If that rate was a touch too fast, then that could cause issues. Uh-oh. All right. That is over here. And that 0-bit counter, we can actually... Oh, no, it has to be set after that because we check it up there. Data 0 count equals 0. No zeros. And then finally, an else. This one, shall be possible after a 0 value. Okay, so we're gonna grab that, put it there. If data started, gap too large. Aha. So this is that error I kept getting before. Right. Data L dot printf. Copy his error matches pretty much. Delta too large after 0. Delta that. Delta. Okay. Oh, that's inside. Oh, Jesus Christ. God damn it. All right. Yeah, so that's the last bit of that loop. Over here. If not, data started. Last bit is that. All right, so here, we're just gonna print this out to the console. How bad could that be? whatever. So format dot print line d dot data equals byte. Clear it out. And grab the last bit like that. No, not like that. Let's put that in there too, just for shits and giggles. How bad can that be? Yeah, right. Bad. It's gonna be bad. It's gonna be bad. But I don't. It's fine. Whatever. Shush. Okay. Yeah. Expect 0 undefined. No. Undefined C. Okay. 165. D dot count. Do I have another one in there? Yeah, I do. D dot count. I'll find data. 173, because that's missing that. I'll find current. Count is at 0. Ha! Okay. That's my panic in there. This right here. Counts at 0. How did he make sure that that never happened? Zero-bit expected. Is that what that was? The 0-bit expected? No. Oh, he just ignores it, doesn't he? So that should just be a return. All right. See what happens now. Whew. Delta too large after 0. 18 to 19. Is this the, which file is this? Oh, okay. So, right. So this is the audio that did not successfully decode with the other, with Sour's code. Let's have a look at wave, the 12, number 12. Because that one I think, or I know 11 actually. 11 did decode correctly. So let's compare that to 11. Really? Huh. Huh. So I don't think I got any printouts. Because it's just hitting, it's hitting this all the time. This right here. Oh, so I just changed that to 19. I suggest that a part of the problem is that you're directly cloning Sour's logic rather than trying to figure it out for yourself. Yeah. Yeah, honestly. Probably. I'm trying to take the shortcut. The shortcut ain't working. What the fuck? Got one printed out, and that it found a lead-in for one of them. That's all it found, though. Oh God. All right, let's back up a little bit. All right. Cutting shorts doesn't work if your trousers have a hole torn in the seat. Yeah. Yeah. That's a good one. That's a good one. Okay. All right. All right. So, let me comment the stuff out. I'm not going to delete it. I'm just going to comment it out for now. So, I won't do any of that logic. Okay. So, if we have the lead in, then we need to read out that. Not read it. Well, yeah. We need to figure out the clock cycle from the lead in, because that's what it's there for, essentially. Right. Head peaks. 9s and 10s. That's what I'm expecting. Yep. I spent a few years blowing out one knee in my pants, followed by a few years blowing out the other knee. After that, it shifted to seats. I stopped ending up with cutoffs. Nice. All right, so we can get rid of that. That one's easy enough, 'cause that's over 10,000 or whatever, right? So that's handled here. Let me find a page, but this is the main pages. These should be these are the major groupings, right? Like each of these will have the lead in, but nothing of a shorter delay of that will have a lead in, right? Right? Over 9,000. Yeah. All right. Thank you. Let's have a look at the spectrogram so we can see a little bit better, maybe. So here's like the main lead-in, right, for each of the pages. No, that's the lead-in right there. No, it's not. Okay, whoa. This is the main page lead-in. And then these would be like the packet lead-ins. The idle pattern, same thing. Kind of. Yeah. Idle. Fine. But this is that 9 and 10 that I keep finding. Right? You know what? Let me hang on. I wanna add timestamps to these, if I can. so I can match up the data here with the spectrogram. The lead is a pure square wave that's a particular at a particular frequency. Was that this stuff? That's multiple frequencies though. The idle pattern is a repeating sequence of various half wavelengths. Oh. All right. I still want to get the that in there. What's the smallest unit for Golang's time? Nano? Milli, micro, nano. A nanosecond. Is that enough? Is this enough for enough resolution for what we're doing? So the lead-in has a single primary spectral line, in this case 2 spectral lines, but the idle pattern, because it repeats on such a small time scale, has a characteristic steady pattern of spectral lines. Okay. Okay. It looks like there's 2 separate idle patterns there, as shown by the different spectra. Yeah, so I did notice, so one thing that's different between English 1 and another one is it has frequencies up here, too. Could I just, like, cut off everything above, like, 7K, 6K? Like right there. Is that our actual data right there? Here's something LPF involved. Maybe that's what Sour's doing with the filter. This guy right here. Grabbing the filter on it. The low pass, just so he gets that one. Yeah. The lower the sample rate, the fewer high order frequencies can appear. Yeah. That's true. Yeah. Yeah, which makes sense why the cutoff up here is like 20K, because that's half the sample rate, right? Because you need 2 samples to figure out what's it? A phase change, right? Yeah. Nyquist. NyQuil? Simply, there was a central principle for digital signal processing, linking the frequency range of the signal to the sample rate required to avoid a distortion called aliasing. Right. So yeah, if there aren't enough samples in there, you'll get like 2 high peaks instead of like a high, low, and then a high, kind of, right? Because you don't have enough resolution in that. Yeah. Enough of that out there. All right. So would I want to apply a low-pass filter to the entire thing before even trying to get any data out of it? I don't know if I want to figure that out, though. I'm getting ahead of myself again. Let me get the timestamps on this stuff. And those are going to be, what, durations? Durations. Which would be these guys, basically, right? Duration. In 64 represents the elapsed time between two instances of an N64 nanosecond count. The representation limits the largest representable duration to approximately 290 years. Okay. So, funny story. If you know that there's energy at a particular frequency that's higher than your Nyquist frequency, you can pick it up by the way it aliases your sample rate. Yeah. So if it's not perfectly double your sample rate, it will be out of phase with it, right? So the phase of it will change at a known rate, right? Whatever happens. Well, no. Be double the sample rate. If you go in the other direction. Yeah, but anyway, doesn't matter. Okay, so parse duration, I don't care. That's the point. Double because we're looking for stuff above the... Yeah, right. Double, right. You're confusing me, Gel Mega. I'm already confused enough. Stop it. Yeah. I don't care about actually part. I'm gonna just set it. Absolute value. Special case. Math min in 64 is converted to max. Huh? Sure. Jesus. Why? Why would you do that? So okay, so what I need to get the timestamps is I just need a sample delta to a duration, and then add that to like a master duration, basically. So the sample delta to duration, I would use the frequency. Didn't we already do this at one spot? I feel like we did. Hang on. Here. Kind of like this. You do that because the absolute value of the minimum N64 cannot fit in an N64. Right. Yeah, okay. Yep. There's also a fun thing where you can get more precise frequency estimation via an FFT by checking phase change and frequency buckets between successive frames. Right, but it can fit in UN64. Right. But duration is in 64, isn't it? Yeah, why is duration in 64? Shouldn't that be like a UN? Or do you expect to be able to have negative duration? I guess you could have negative duration. Well, whatever. Because if you're doing a delta... Yeah, okay, I get it. All right. Yeah, okay. So, decoder. Let's pass in the sample rate. Like that. This is something... No, so this is sample rate on the actual data file itself. So we can just okay, yeah. So this isn't the data necessarily. And then this is going to be write dot sample rate. Is that what it was? Write dot format dot sample rate. Format dot sample rate. Yeah. Those wasn't used as special case for the absolute function. I don't know. Negative min equals max plus 1. Tell that to a one's complement or sign magnitude system. Okay. So adding in the sample rate. Rate like that. Func decoder. Sample delta to duration. Delta int time dot duration. Okay, so for this, we're taking the sample. Nanoseconds per sample. I mean, maybe. So why am I blanking out here? IEEE 74 just chat. Talking about signs. Both plus and minus 0. Wee. Big Blaster, how you doing? Monitor. I don't know that one. Right. So nanoseconds per sample. Let's just get this. Float 64. That divided by float 64 d dot sam d dot rate and then just multiply that by the delta. Multiply that by the delta. Duration is that. And then I just need to get that into a time dot duration. Is that right? I don't know if that's right. I don't know. Let's do delta to duration. Oops. Delta to duration. And then found page at there. Yeah. So. Yeah. So okay. D dot delta to duration. Rate and define. Decoder is a method rate. What do you mean as a method rate? Oh, it's sample rate, isn't it? Sample rate, not rate. What? Undeclared, declared not used last bit. How dare? Delta 2 duration. What? Delat. Spelling. Okay, I got a magnitude off there. Found page 16 at 1.89 seconds. No. Woo. 260 might have been meant as last bit. Oh, that's outside the loop, so that's fine. That's set to 0 when I initialize. By not being set, so that's the 0. That's fine. Yeah. Because that's creating the variable up there. I don't want to print that out right now. Okay, so so I'm off by an order of magnitude or two. That math is just wrong. How is that wrong, though? Actually, having microseconds, we had some terminology confusion when we wrote it. Wouldn't that be wrong in the other direction then? What the hell is... Originally, I had it as MS. Is this still... What the... I'm off by... Yeah, okay. There we go. That's better. Okay. That's better. Found page 0 at 27 seconds. All right. .7, right? That's 6.8. Close enough. Okay. Next one, 1 minute 20. Yep, right about there. Really? $120 over here. Let me actually look at the same data file. That. Why is it still trying to write out the data? I thought I commented that crap out. No, I commented out that. Okay. I love the huge DC component in the spectrogram. Yeah, the spike. Oh. All right. 27.72. That's more what I was expecting, right? 7.5. Oh, 27.72. Yeah, okay. That's better. All right, so it's right there is the first page. Okay. Second one. 118. Good. So it's finding this then. 140. Let's zoom out a little bit. This guy right here. 542. Five. 540. Wait, I should be finding this guy right here. At 220. What the hell is this? 255? 254-ish? Right? You should be finding this. Do I still have that turned on for you guys? Those are probably the ones you remove by changing the 70K to 7 to 70K. All right, so I changed it to 10. Changed it back down to 7. I should have got a lot more this time. I love the sound of data in the evening. Yeah. Do I, yeah, I got the turn on for you guys. Interesting. What was the delta cutoff? There we go. Okay. So now 27, 118, 140. That was right there. Okay, 140. I expect I got that one before, I think. Next one is 253. Okay. That's that right there. And then 254. Okay, well, so this one's a bunch of nothing, though, isn't it? You bastard. Oh yeah. Oh, that's just okay. Yeah, it is a bunch of nothing, because it's just the start of the thing. That's very all right. Yep. Audio singles, yes, probably used for something in the audio track. Used for something in the audio track. Maybe I shouldn't have gotten rid of the audio track. You're saying? There's nothing up there. Nice DC offset. Yeah. Yeah. So that's just some noise introduced, going from nothing to something, essentially. Yeah, that's all that really is. Same over here, right? Yeah. Oh yeah. Oh yeah. Wow. Wow. So that's if I can safely ignore. turn the spectrogram back on. Yeah, so this stuff I can ignore because that's just it figuring out where it was again. Yeah. Just after active data region, go to one that isn't. It's like one of these. Oh. Zooming on this is kind of garbage because it like doesn't go to where your mouse is. Right there's in there. This stuff here. That little wonkiness. A proper audio gap. There's a proper audio gap right there. Zoom in. Yeah. Some more of it, yep. Oops. And that little dip right there. Yeah. Anyway, yeah, so 254. What was that? 54. So it's this guy here. 542. Yeah, it's finding all this stuff. Right, because it's not dying on that because this is it's between packets, but it's inside a chunk. Tape is AC coupled. It's a natural bandpass filter. I'm not sure I know what a bandpass filter is, honestly. These guys, I don't like those. I don't like these that are just like interspersed in between here. When it's not the standing wave, right? Not standing wave, you know what I mean, that. Five 42. Then 8 something. 625. Oh, it's finding these dips. Okay, so it's just finding the dips then. The dips of nothing. Right? Yeah, okay, so it's finding the dips of nothing. Right, okay. Which is fine. That's fine. Thank you for the follow. Appreciate that. Finally looking at my compiler again. Still at the parser stage release. I got something. Lists, token, and AST. Nice. Mid-chunk lead-ins without gaps? Yeah, right? You're getting there. Oh, yeah, I don't know. What was the delay packet? Wasn't that like, hey, we're starting a delay, and then as long as a certain signal was given, it was still in that delay? Was that the delay packets? Or do those have like a set time in them or something? I forget. Because that could be what all this stuff is, right? That could be the delay packet. And it's just decoded into the ROM file as delay this amount of time. Right? Instead of, hey, you're still seeing this byte, just delay. The NOP byte or whatever. The NOP, yeah. Which would be all this stuff here. Looks like the usual delay value is repeated AA. Right. Yeah. So in the actual data, it isn't like an opcode and then the length. It's just, hey, here's a delay. You're delaying now, right? Just keep delaying because he still got the thing. Yeah. So impressed that it was less than 100 microseconds in debug build. Is that microseconds? I forget the symbol, the notation. Yeah. Okay. 751. Is this another gap? Yep. 52, 825. Another gap down here. 47. Yeah. Okay. There's a few of those. IQ handle looks like it keeps reading bytes until it sees a C5 start of packet. Yeah. Yeah, that makes a lot of sense when it's like just playing audio, right? Like during a scene, just playing audio. Something's gonna be on the data the data end of that. So that being a don't do anything right now makes sense. I don't have it on my keyboard either. Yeah, I think I will keep it that low for now. Just so I can like get what the hell is all this? Just so I can get the data itself out. Oh, is that the is that the quiz at the end? Is that what this is? It is.
英語で自分の名前を言うときには名字と名前を逆に言う。A, yes. B, no.
Huh. Sell one of the small trucks. One of these guys here? It's got data going here. A little bit of lead in. This is just the, yeah, that's just settling. Only for this small one. This one here? This fucking zoom. Yeah, this is just these are all the same here. Nothing different here. Yeah. Yeah, so that's the delay again. Right? I don't know why it splits like this though. Like why there's that gap there. Yeah. I mean, it's got like It's got that with all of them, which is weird. I wonder what the script is doing at this point, you know? If the small one has a lead in or not. No. There's a DC also be a no lead in tone. Yeah, no lead in tone. And this is the, like, so it asks the question, and then it waits for me to press a button, right? Which that's the script going. And then when I press the button, it continues on to the next one. So I'd be curious to see what the script is doing at this point, you know? Then again, the lead-in tone has to be able to pick. Then again, the lead-in tone has to be able to be picked up while the tape is moving at high speed. Well, not these ones, because these ones you can't like jump to, right? So you can't like say, "Hey, I want to go right here." You have to go to the larger lead-ins. What is this?
Power up!
Yeah, so I can jump to here, but I can't jump to over here. Yeah. So I guess it'll be able to find like this lead in there. That's... How long is this? About a second? A little less than a second to lead in? About a second. Which, I mean... Yeah, alright. This is why, this would be why it's doing peak detection instead of sign or edge detection. For these lead-ins? God, this fucking Zoom doesn't go where I want it to fucking go. It's so annoying. I want to go, like, right in here. Zoom into that. Yeah, so it wouldn't, like, pick up these guys. What's going on here at this point? I said mute that. These data packets here? Like, is that, like, enough space for that crap? They would be very large data packets, that's for sure. Huh. I was thinking for the small ones, how it synchronizes to actually read them without a lead-in. I don't know. Maybe we'll just use the same sync from before. What the hell is it zooming into? Is it zooming into like my cursor? Is that what's happening? It's so fucking frustrating. Nell Manny, how you doing? Welcome, welcome. There's also the possible maybe it doesn't need to have to sync up for that. Yeah. So for the stuff that's like small enough, I don't know. Where is this? Is this? Yeah, this is.
Yes. B. No.
Yeah. So this is during the quiz here. No. Small as it doesn't need a resync. Well, then again, the tape does physically stop between these questions, which I guess that's where this would be, where this comes in, right? The resync there. Is that what it is? Plan C internship. Oh, nice. So during the play, right? You get the repeat or next page crap, right? But you can't jump to those places with the page number. Are those the ones that have the lead in then? Or wherever a tape would stop? Oh. Only for a delay packet, so the actual data may not matter. Video game promo. Ooh. Nice. C#. All right. Not bad. Not bad. Well, at any rate, I need to get back to some of this stuff. Plan C? I don't know. Plain C? What's peak? What? Oh, wait, peaks. Okay. Symbol delta. Okay, and then let's get S, and that's going to be D dot delta to duration I. Nope. That's not what I wanted. Got a backup plans? The may well be why it has lead in for those to ensure it can find them after the tape stops. Come on, where's the data start? Let's go. So, all right. So I'd want to find out the clock cycle out of this, and then have that as a value that I can be like, all right, how many clock cycles are in this thing? Right? Maybe it would just be the mastering artifacts. If it stops at the first drop, then I resume. It keeps going until it finds a lead in. Could be. Could be. I suppose once we get an encoder, we could start like figuring out how much of it actually matters. Yeah. Thankfully, colleges here approve internship for at third sector. Volunteer stuff. Oh, nice. Legally rejected by the companies and the state. Oh. Okay. So do I want to take like an average of the last, while we're in the lead-ins, the average of the last however many cycles to get the clock cycle on it, to get the What's it? The cutoffs? Can I do that? I figure the distance and lead in and using that later to find the number of the distance between edges. Yeah. Not doing an average yet, but I have that as a to-do. Yeah. All right, so let's start working with durations and not sample count for figuring stuff out, right? So clock duration. Well, let's do one of those. All right. So then here, no. Here, when we find the page, oops, what? This is where I can go, all right, we're going to grab the last whatever. Yeah, because those are at all the starts. Found page at 27.7. But that's the very, very beginning of that, isn't that? Yeah, that's right there. So I'd want to go what? A microsecond? An average it there? See how many clocks are in a microsecond, and then figure out the distance averaging those? Does that make sense? If find clock. I don't see how root translation will be easier than simple count for this, but I might have missed something. Because I don't want to be tied to 20 about 4,800 bits per second in theory. You're right. I don't want to be tied to the sample rate itself. Right? So I'll figure out like the duration stuff here. I'm figuring out what the actual clock cycle is in the samples. Right? And then using what I figured out there, I can be like, all right, this is the sample rate. Well, this is the clock cycle rather in samples. I can use that to figure out what everything else is. Instead of hard coding it, hey, if it's 11 samples, which dies as soon as it's not 41.1 kilohertz. Exactly, pretty much. I thought a sample is the duration of time 2, just define that as the duration of 1. other 4800 BPS for that matter. I just use the lead-in to figure out the time between bits in whatever time unit of time I'm using. And for me, that unit is samples. Yeah, so I'm using well, yeah. It's about 9.1875 samples per half wave. Right. What I want to... Well, so this is ignoring like what the file format is saying the sample rate is, right? And I'm figuring that out from the actual data in the file, instead of being told, "Oh yeah, this is totally 41 or 44.1 kilohertz," right? 4.459. Yeah, that per quarter wave, which is the actual base unit you need. Which is the 9.1875 divided by 2, right? I can't do decimal there because why? 9.1875 divided by 2 is the 4. Yeah, okay. So I don't see that I need them. Well, I'm doing it anyway. Remember, I'm figuring this shit out, so maybe this will help me figure it out. I don't know. It can be simplified later. All right. Two-letter extension. What? If you're ignoring the audio sync, you basically need to separate the half waves into 3 buckets by length. If you want to use them, go ahead. Might help. Might even help for all I know. Not that I know. Yeah. All right. Find clock count 0. If find clock count is greater than 20. Arbitrary number. Basically it's counting the peaks, right? Find clock is false. So we're not trying to find the clock anymore. And we're not going to have any data during that. Also, once you get a lead-in tone, the inner peak distance will average out to what the actual speed is. Right. That's kind of what I'm doing here. So I'm grabbing a bunch of peak cycles, and from that I'm gonna average out the times. At the very least, I'm gonna see what it is, right? Yeah. So. Find clock. Deltas. Two, 3, or 4 half times. Yeah. Yeah. Else, find clock count plus. Let's put this in there. Oh, no, put that in there. Find clock deltas. And delta duration, sample delta. That. Okay, so then here we've found it. And then well, time dot duration. Val plus equals. No, I already know the number I'm doing, don't I? So what if I just make that instead of a slice? Var time dot duration. Like that. Equals. Can I just add, or do I have to go through like a time dot add or something like that? Duration dot add. Can I just add two durations together? I'm gonna try it. Plus equals. Yoink. Paste. Then here is just going to be val equals divided by 20. Clock. Well, let me do this. Probably not. Nope. Declared not used. Clock direct. What? Where is that declared? 263. I'll find val. Yeah, they're just integers. Oh. I see. Fine. It's fine. That's more variance than I was expecting. So 310 is a bunch of it, sure. There's also 218 at the very end. And 327, 217. That varies by a lot. I'm just curious now. If min clock is 0, if max clock is less than or min clock is less than it's greater than. Min clock. Max clock. Yeah, the start of lead in, right. Once you have more than 20 deltas. Good point. Yeah, okay, yeah. 204 and 307? That's... what? Looks like 291's kind of common, too. Let me, log that. So it lines up at least a little better. I don't like that at all. I don't like that at all. Yeah, even these like last two ones, 291 and 207. Noise is part of it, isn't it? Probably better to take the average at the end of it. I mean, that means I have to find where the end is. But you are right. Yeah. Yeah. But yeah, so I've got to find the end of it. Or at least find... or not find, but at least go a bunch of samples in. Let's say 100 for now. Delay it for 100 samples. This would need to change based on the sample rate too. If find clock delay is greater than 0, minus, continue. So it skips the first 100 samples, and let's see what it comes out to now. Went to 207s. 374. Not as bad, but still not that great. What happens if I delay by another 100? If If I delay too long here, like that will run into the actual data itself. 6 and 375. Ever so slightly closer. That's still more variation than I was expecting, though, you know? 207, 374, yeah. Yeah, that's between... Yeah, plus or minus 1 in there, yeah. 207, 206, 270, 375, 374, 373. 207, 208. Yeah, what the heck? Why? Oh. Is one of those like way off? What's that 751? What is there? Are these the ones without the lead-in? 625. These are the ones without the lead-in. Okay. So, huh. So if the clock duration is 70 or so nanoseconds above, more than 50 nanoseconds higher than the clock, that's not a new page. Basically. Right? All right, so let's have a look at the first one here. 207. Okay, so this isn't really found page, it's found gap. All right. Clock duration. We're just going to take the average on the first one, right? So fine clock. If duration is greater than 0, fine clock is no. False. Drop this in an else block. All right. Actually, no. No. Clock duration. This. CD equals. Yoink. That. If it's 0. If you actually detect the lead-in when it ends, then you'd probably see these blocks having the lead-in end immediately or something. I mean, I suppose. If else if CD is greater than it's greater than the CD minus no clock duration is greater than no minus CD. I need time dot parse duration. I don't like having that there. The 50. Oh, because this is in microseconds, not nanoseconds. Not a lead in, and that's going to be CD like that. Um, 50 US. Time dot duration. There equals time dot parse duration 50 US. If error is not nil, panic error because I don't care. What do you mean declare to not use? Oh, because... Wait a minute. I broke something. Yay. What the hell did I break? Oh no, clock duration. Okay, clock duration is never changing. CD. That needs to be CD. Like that. Because this would be this is just the master clock or whatever, right? Let's try that. It's not doing the what I thought it'd do. Uh, Can I do that? Sense? No. No. Well, yes, I can. Right here. This one. Sense. Time. Time! Damn it! Shorthand for now.sub-t. It's not what I want. No. I think that's not... I don't even know what I want. What do I want? I want that to work. What is that in? Oh, hang on. Wait, what am I? 50 times time dot millisecond. Why don't I just do that? What do you mean? It's 2 L's. It's 2 L's. Microsecond. It's micro. Not milli, microsecond. Is that what? No, that's the line. Huh? It's never hitting the non-lead-in. That's actually what I'm trying to do with that. I'm trying to, like, isolate these guys. This is, right now, this is more of me understanding how to deal with time, though. Not necessarily anything to do with the samples themselves and the actual data. This is more understanding how to deal with and handle time. Which is... I'm not doing great, obviously. Oops. Why are those negative? Because that's going to be larger, that's why. There we go. So you're trying to detect that you don't have a clock by checking if the calculated clock is slightly slower than what you expect. Yeah, detecting that, like, oh, we just had a gap. There's no lead in here. That kind of thing, right? That's not really what I'm doing, though. It kind of is, isn't it? Hey, this is too far off the expected clock. which means this can't be a lead-in. Be interesting to see if there's some consistent pattern to the data before a gap. I mean, I think it's all just the delay. Whoa, that's not the key combo I wanted. There's another one. There's that one, yeah. Delays. Delays. Oh, there's a little blip there, but I don't think that's actually anything. Come on. It's fucking zoom. I swear to God. I don't even know where I was. I don't even know what I was trying to zoom into. I don't even know what I was trying to zoom into. A little blip there. Oh, that's just... Yeah, I don't know if that's any data there. I mean... Maybe. A little blip of something. I think it was right here I was trying to zoom into. Right there. I don't know if that's anything. It could be. Some shorter stuff here, some longer stuff. I don't know. Averaging the first 20 bits, not looking for a gap. Right, well, the gap is filtered out with the is clock. So that gap, or the peak rather, right? Current peak. If peak is none, don't bother. So peak, this guy here. Didn't I clamp this somewhere? Yeah, peak delta right here. The clamp. Right? So it's under a value of 500. It's seen as nothing. There's nothing there. So it goes until it finds nothing. Peaks on edge side. Suppose that non-lead-in data will always have a longer average delta time than lead-in. Then the question is by how much? Might be better to see if we can see those peaks. Those first peaks are consistent enough to be lead-in. Yeah, it doesn't look for the gap because the gap's already gone. Right. Yeah. Well, I think at least in the data that I have, the at the end of a gap, it is always either the delay stuff or a lead-in. It doesn't look like it's ever anything else. And for the larger gaps, especially, it's lead-in. Like that large gap lead-in. And those might be like, yeah. So those would be like the full pages that you can select. Whereas the shorter ones are probably the what's it? the again next page selections, right? What is this audio right here? No, not solo. That one's solo. This one.
名前が言えるようになろう
Yeah, so that's the intro right there. That's the like the unit title screen, right? What is this? This is 1. So that's
It's your
this.
名前が言えるようになろう
That's that. And then this will do.
hello.
Oh, that just jumps right into it. Okay. So that just jumps right into this stuff. But I can repeat this. And that, what?
Oh, it's nice to meet you too.
There's actually just such a long delay here. I thought when playing through this, hang on.
Hello. It's oh.
It's the delay so you can read the damn message. All right. So during all this, it's showing the message on screen. And then after that, message is determined to be, all right, that's long enough. I guess it'll like hit that? So then, here in a second, it'll be like, hey, you want to do it again? Right here. And if I hit again, that should just go back to the top of this. Right? Where they're dancing again. These ones you can seek. Yeah. Yeah, so if I select page 1, I think it comes up to here. Or here? Yeah, okay. So page 1 is where you start, because that's the what's the default, right, on that menu. So yeah, this would be page 1, and then this must be the start of page 2 then. As you can see, to not necessarily via page selection, right? Look at the spectrogram a little bit before the gap. That was oh yeah, this right here. Did I just what the hell did I just hit? I had to zoom out. This guy right here. I don't know. Looks like it might be something. Something there, and then there. Another one there, another there. But yeah, so let me, hang on, cause I'm curious now. I don't even have any of them open right now. Oop, too far. ROMs, English, 1. If I say page 2, where does that bring me? I'm gonna guess it's gonna be the title card for Unit 2, not directly to Brother Chance, right? Okay, title card for Unit 1. Excuse me, the unit title card.
名前が言えるようになろう
When I hear repeat, where does that go back to? Speed up a little bit.
Hello.
Yeah, going at triple speed kind of breaks the audio. Don't worry about it. I love how I can still see it flashing at this speed. Alright. Speed, normal. Okay. Does this go back to the title card or the back to the dance? The dance. Okay. Yeah. So the lead-ins are places that you can skip to. Not necessarily that you can navigate to, but you can skip to. Yeah. The repeatable blocks. Essentially. Oh, there's another one over here, isn't there? Look at that. That's curious. Oh, god damn it. Son of a bitch. Let's fucking scroll. Then here, there's also one, but it's a lot sooner. As if, like, that wasn't supposed to be there. This one's got a few of them. Huh. And then a lot sooner, as if this gap wasn't supposed to be there. That's weird. Could that just be like a synchronization thing for the scripts? Different terminal data packets, yeah. Maybe something that like the script is looking for in the data stream. When it's going through these this data, when it's reading this data, it stores it somewhere, right? So the script could also something to turn off the tape motor. Oh, so like not having to wait for the script to tell it to turn off the tape. Not if it's the idle packet. Hmm. Yeah, that'd be interesting. What is this right here? Swim a little bit. Okay, that's part of everything else. You said earlier that the idle packet, which this looks like, reads up until it hits C5. So it was the start of the next packet or something, right? The delay packet. This one? Or no, hey, was that in Source code? There's something about C5 in this. Where was that? It's over here, I think, right? Yeah. That's the very beginning of the data. Sets things up so that it treats the C5 at the start of the next packet. At the start of the next packet, right. IRQ handler pseudocode text. I don't know. I do. Where's that C5? Oh, there it is. Another one? A few more. Okay. End delay. Set the packet state up as though we already read the C5 start byte. This works because we checksum C50505 to get here and then stop summing checks. Is that the checksum on the delay packet? Is that what we're seeing? But it just encodes more delay just for shits and giggles? Delay packet doesn't have a checksum. Never mind then. So, does it like pretend to start a packet? Is that what that's doing? Is that data like eaten somewhere? Oh. Oh. Just end delay early. You literally can't have a delay packet with a 00 byte. Huh. Delay packets ignore their contents until they see a 0 error or see a 5, which is the first byte of the next packet. So does that mean it skips over those gaps? Because those wouldn't be anything, really. Which gives you a 0? I don't think so. I don't think it would get. Yeah, we don't quite know what's going on. Yeah. I don't think these gaps would be passed along by the hardware, honestly, because nothing's encoded there, and a 0 is something technically. Yeah, these are 0s right here. Oh, wait. Hang on. The lead-ins are zeros. So... Is that handled by the ROM? These lead-ins? The arc handle is only enabled after the lead-in. Right. Okay. So the ROM never even... Well... The ROM decodes the lead-in. Well, yeah, so the hardware does do the decoding because it gives us back a byte when we get an IRQ. Right? We're not decoding we're not decoding the waveform in the ROM. The waveform's already decoded in hardware, and that's giving us back the actual data. Which is why we can decode this to raw data packets or raw data. For the emulator, we don't have to like re-decode the audio. You know? Which actually doesn't have the lead-in stuff, because that's stripped out by the decoder, isn't it? The or not stripped out, but like it's all like reserialized as the packets and whatnot, and the pages and all that. Yeah. The hardware decoding, and the hardware handles the lead-in, I assume, since that's how it synchronizes its timing to read bits later. So the ROM waits for a solid detection of data, then for the first start bit of the chunk, at which point it enables the MFM decoder. Wait, so the ROM itself can enable and disable the decoding, and it can read just the raw waveform off the tape? IQ handler turns the decoder off and back on after each byte read. Oh, God. Don't know how flexible the actual hardware is here. I don't know. No, because that's not in this terminal. 4202. Is that in here? Page drive status. This here. This one? The read on that? Or the right, yeah. Output data bit, hex 40 unknown. 20. Pulse load to reset the drive controller. Pulse load to clock a data bit. Maybe tape audio enable. IRQ enable. Decoding enable. Oh, yeah. Data decoding enable. Does the page seek happen in ROM? It would have to, at least a little bit. Yeah, I'm not sure if this is a toggle on it, but just maybe turning it on. I don't know. Commands sent to the tape controller include seek commands for a number of pages, gaps. Might not be much use, much to enable, but a shift register reset or something akin to control reading? Because it does after each byte. Yeah, I could see it being a shift register internally, because we are clocking bits off the tape, off the waveform, a bit at a time, not a whole byte at a time, right? So yeah, I could see it internally using a shift register, to get the full byte, and then firing an IRQ once that shift register fills up. But not really having any automatic way of knowing when that value's been read and used or whatever. So it just leaves it up to the ROM to be like, all right, tell us when you want it cleared. Right? The first thing that the handler does after reading the data byte from the tape is to lower 4202 and 1. It's this right here, right? The resume label. Status, yeah. And 8. Our data input ready. Oops. Yeah, so it's waiting for that shift register to start up, waiting for the next byte. Yeah. Then re-raises that. Oh. Where's it looking at here? There. LTO? I'm not sure what that abbreviation is. We're doing stuff for linear tape open. Liner tape open. What? Tape backups. No. No, we're working on stuff for this thing. It's a study box. It's a Famicom cartridge device. Edutainment kind of system. Data on one track, on one channel, and audio on the other. This is one of the tapes here.
Hello.
It does stuff like this.
Hello.
His audio tapes nothing near as fancy as modern digital tapes, right? Yeah. So these are audio tapes that have data on them, as well as recorded audio. And this is tape quality audio on a Famicom, which is like, I don't know of any other any other system that, any other game, whatever accessory on the Famicom or NES that has this quality audio. honestly.
I'm Akira. What's your name? What's
The
your
animation
name?
quality, on the other hand, with the flashing, that's
Arnie.
a different story right there.
I'm Arnie. It's nice to meet you.
Makes sense. Russo got an
It's
LTO.
nice
Okay,
to meet you.
gotcha.
Oh, it's nice to meet you too.
But yeah, so this is for teaching Japanese, teaching English to Japanese kids. Yeah. I'm working on rewriting a utility to decode the actual audio from the waveform into a ROM file. Eventually, I'll do the reverse of that. Take the ROM file and re-encode that into a data file, into an audio file, rather. With the idea being able to write my own tapes essentially from scratch, which would be nice. But we're a ways off from that. We're a little ways off from that. So, let's pause that. I don't need that. You don't want any more. But yeah, so I'm trying to understand MFM and modified frequency modulation encoding, and specifically how these tapes are encoded. So the bottom here is the data, and the top is the recorded audio. Yeah, there's weird like gaps and shit in here that don't make too much sense, honestly. So, yeah. And I think I'm getting a little distracted on that instead of trying to decode data stuffs. All right. Okay. Might be easier to make sense of them in the blip of the data before them once we get them decoded to bytes. Right. So that's really what I need to do. Is I need to decode this stuff into bytes. Right. All right. So I have the clock at this point. Right. I've got a clock. I know what the clock is now. And then using that, what do I need? The half of that duration, half the clock for this? How the hell does this work? Oh, that's not what I wanted. I'm looking for that. I see. I had some other stuff open here. Yeah, the non-return to zero stuff, which is related. Yeah, non-return to zero inverted, also known as non-return to zero IBM inhibit code or IBM code. Right, which is similar to what we got, but not quite. No, what was? Hang on, let me go back to. Is it this one? Yeah, this one here. So it's not like that a transition happens. It's when that transition happens. Right? So if the transition happens on the clock cycle, it's a 0. If it happens mid-clock cycle, it's a 1. The clock you recover from the lead-in is twice the duration of the clock you need to count the half bits properly. Okay. All right. So up here. Half clock. It's been a long time. Still today done. Okay. So, okay, and then half clock equals CD divided by 2. Well, that's going to put that out at the top, isn't it? Ugh. Half clock, 103.741. Okay. Right. No, where's the yeah, because I given the sample. I don't like the fact that I'm giving the sample in here, the sample rate in here. I'd like to be able to determine that on my own. But for now, I'm not gonna. That's fine. Well, because here, now I want the number of samples per bit. Essentially, right? So I need to take the half clock duration and get the samples from that. I can spell duration correct. Goodness. It's basically the inverse of that. Inverse of the God damn. The inverse of this. Let me refill this. I'll be right back. I'm back. Oh, hello. Hero, how you doing? Welcome. Sorry, I was getting some more water. I'm taking a piss. Welcome, welcome. I am doing some or trying to figure out decoding. How you guys doing? How's stream? Welcome. Yeah, so this decoding is for this guy right here. This is a study box. It's a little tape drive thing for the Famicom. Audio on one side, data on the other, or one track, data on the other track. Looks kind of like this. I could have swore I had that command. Do I not? Does that command not work? Yeah, we're trying to figure out how to take this data and make it data. Make it not audio. Because it sounds like this. Oh, there it is. Sounds like that. Just lovely, isn't it? But yeah, so I'm doing a lot of figuring out of what things are and kind of how math works. And yeah, I don't want this. I don't think I want that. I think I need to actually set that the samples per half clock. Yeah, I want to set that like I want to half clock duration time duration. That's gonna be an int in samples. Half clock. Yeah. So I need to take maybe I do need to do that other thing. Do this here. Well, let's get this anyway, just so I can have it, I guess. Okay, so it's not a delta. I don't. Well, yeah. What? I need to solve for this essentially. So I need this over here. Right? My algebra is failing me. My basic algebra is failing me. Oh, I should have paid more attention in school. Oh wait, what the? Oh, I look out to my teleprompter. And Stream Elements is up there, but it's not over here. All right. Thanks, Twitch. Whatever. Why am I blanking on this now? I got a notification over there. I got a gift sub to Iron Mouse. Thank you, kind stranger. All right, sample rate. Why can I not think? Why did my brain stop working? One bill sample rate times delta, which is also duration divided by one bill sample rate. Yeah, so so divided by Yoink. Paste. Sample. Rate. Which is all delta equals wait, what? Your notation there is confusing me a little bit with the combined bullshit. Well, that's Twitch doing that. The fucking combined ligature. I don't know what that's fucking called. No, because it doesn't do that up here. Yeah, there's duration equals. Nope. Gamboy, how you doing? Right. And then duration divided by times delta. Yoink, paste that. Equals delta. And put that on the other side of it, right? Okay. Duration times sample rate divided by delta? I just need this one though, right? Delta equals duration divided by that. You know, as we sometimes, yeah, no worries. Yeah, I don't know about this. What did I call that? Duration of delta? What, duration of samples? Duration to samples. Half clock. What happens there? What does this give me? Errors. Math errors. Because it doesn't like doing that. Cannot use half clock variable type int as time duration. What? All right, we're just gonna use fucking int then. Fuck you. Half clock samples 4. Does that sound about right? Let's do this real quick. Well, for this, I mean, I'm going to be counting discrete samples for it, so I can't have half a sample. Half a data point. God fucking... 4.57. Well, I don't know. To the closest? I don't know. I don't know. Past duration and cast it to iteration of the method? Yeah, I could do that. I've already changed it, so oops. Yeah, because I want to use this as like the what's it? The interval at which I figure out the bits. Need to exit the range around the value anyway. Right. Maybe you probably should define explicitly and not rely on the implicit data casts. I do like passing the duration type in over here though. And just time. Nope, that's the wrong one. I want this one. Put this after the loop just so I can see it print out. Jailworker, how you doing? Out of curiosity, what library are you using for getting the audio or data off the device? Off the device itself, I'm using a tape drive and Tenacity or an audio recorder to get the data as individual samples. Do I still have that open? I don't. I know, I saw the compile error. I'm using the stuff. Go audio. Come on. Copy that. And make sure I get the address right. Did I close out of the fucking... No. These guys, right here. Paste. And yeah, this works well. This works well. I haven't had to really futz around with this too much. It was mainly just me figuring out how fucking Wave worked and the channels, which was pretty straightforward. A lot more straightforward than the bullshit I'm doing now. But I basically just pass in a Wave file. It splits it out into left and right audio buffers or sample buffers. One of those buffers I am discarding right now because that's the recorded audio, and I'm not trying to use that right now. I just want the right track, which is the data track. Be aware that the libs may be dormant as we saw on Friday. Yeah, not that Wave changes that much, but yeah, these might be dormant. Yeah, which reminds me, I need to actually write up a pull request for. Clone not taking everything. Not cloning everything, as we saw on Friday. Yeah. I absolutely want the channel later, but not right now. That's gonna be stuff like when I have the page boundaries, I need to grab those boundaries. I need to grab that start and end from the audio track and save that as its own WAV file, essentially, right? So I need to chop up the recorded audio based on page boundaries in the data, right? So can I not do any of that? Thank you. No. Yeah, so there's no like recorded audio during any of these gaps, as you can see, right? Yeah. So this audio right here goes with this data, like period, right? It's like scene audio or whatever. This right here is the intro, right? Like the main jingle and title card, right? A big delay in the data, but that audio goes with this data. Not yet needed to do audio processing and Go, but I expect I will soon. Ooh. Although all I need to do is detect an audio delay. So probably just play DTMF detect it come back into the system. Yeah, I'm doing a bit more than just figuring out if there's a delay or not. I'm trying to get bites out of this. It's been a learning experience so far, that's for sure. Quite a learning experience. All right. Cannot use that as int in assignment. What? Huh? 314. 341. I'm dyslexic apparently. 341. Half clock. No, only the time dot duration. No. Yeah. Yeah. That one's in samples. Which is going to be, yeah, assigned here. So we're not going to use that yet. The trick there will be you either need the program to use the audio devices directly from Go, which we're not doing here, right? Be careful with exactly how you do the playback recording, so that the Go program will later analyze. All right, there we go. Half clock, 103 microseconds. Half clock samples, 4.5, roughly. So every 4.5 samples, I need to check for bit. But that needs to be like an upper bounds, I think. I need to have the leeway in there, I think. No. Maybe I should just move that way up here. You can't see the time now, but whatever. It's the midpoint of your bounds. That's true. So I need to add something to this to get the upper bounds. Or I need to take this and subtract and add stuff to get the bounds, the low and high bounds. Do I want to do that? So I can't go too high. If I take half of this again and add that on, would that be my bounds? What am I trying to do? I'm trying to not hard code in samples. hey, if it's this less than this many samples, we've got a bit. I want to figure out what that is first, and then go, hey, if it's less than what we figured out, now you give them transition point is partway through a sample period, so you should be able to estimate how far through the sample period it is. You're already getting the distance between the peaks, so yeah, you need to compare that distance to the various multiples of this bound to figure out which bucket you're dealing with. Okay. Right. And how many of these can I have? How many buckets can I have? Is it 3? That's how it's divided up here in 3 separate buckets, right? And these guys here, 11, 15, and L's. 11, 15, and an else. 4 half bits. So 3 buckets? Plus error cases. Yes, peaks should be either 2, 3, or 4 times this distance apart. Okay. B1. Two, 3. And then to handle the variability in tape speed, etc., you need to not just check for exact multiples. Right. Delta between where you calculate the transition should be, and the delta between where you calculate the transition should be, and where you exactly expect, where you calculate the transition should be, and where you actually detect it tells you how wibbly the tape speed is at the transition. Presuming that it actually makes a transition there, but that's data dependent. And you're guaranteed to transition within 4 quarter wave periods anyway. A quarter wave being a half clock. Right? Because a full wave would be high, low, high. Right? Half that being a high, low. And the quarter being high to nil. Right? Am I understanding that correctly? Maybe? A full wave is the high and low sides. Right, it depends on like where the bounds of it are though, right? But it's the same length. From high peak to high peak would be a full wave. That's the phase is offset a little bit there, but from the edge to the other edge. From peak to peak to peak, right. Right. Yeah. Shit, what's the name of that program? This one. New file. No. 256. 256. Yeah, so but can I get like an actual color? Baseline, right? And then hang on. Wait. Oh my god, I can't actually get a decent. Close enough. Dennis, how you doing? So peak, right? This right here would be a quarter, right? How you guys doing? Welcome. This would be a half. And then this would be 1. Right, okay. Doing well, that's good to hear. Wreaking havoc with Vim and FreeBSD on an old Spark 64 server. Nice. Mars Raptor, how you doing? Today we're figuring out modified frequency modulation. Your square waves looking very synovial. Yeah. Sinosodi. Yeah, that word. So this is all this is all for this thing right here. Just a tape drive for the Famicom. Recorded audio and on one end and data on the other end, on the other channel. We're ignoring the recorded audio for now. And we're trying to get the data out of the audio wave. So I'm figuring out how audio works. It's a journey. Now, technically, it would not be necessary to be a quarter if it's long followed by a short. It wouldn't be a mathematical quarter. Right. Yeah. Low pass. Damn it, keyboard. Low ass filter. Here's the thing. At one time, this was cutting edge. All right. So I was doing a ton of bitching about my Sci-5 Risk 5 board that I now call a Scam 5. Oh no! Lower left of the board. See lower left little board. Lower left, this little guy right here. Right on there. Oh, not there. This little guy. It's a scam board. Uh-oh, what happened? A tiny little board. That shitter. Is it being that uncooperative? Yeah. Speaking of Risk 5, Kevin Pye, did you ever get your Risk 5, what was it, a laptop? Did that ever come in? Aren't you going to do something with that? I haven't done any Risk 5 stuff yet. Maybe in the future, I don't know. It's fucking slow! I mean, that's expected, yeah. That's to be expected, it being slow. Need to reformat it, uh-oh. Ooh, it looks shiny, though. I'll give you that. Tiny little heat sinks. I assume this one here is the processor. And what would this be? With a very expensive Samsung 990 SSD. Oh, this little guy right here? Yeah. Yeah. 2 gigahertz? That's half the speed of one of the cores here. The whole thing is a big disappointment. Oh no. What makes it a disappointment? I'm genuinely curious. Yeah. Is it the general Risk 5 nature of it, or is it how it was packaged? and everything around it. Oh, there's a little SD card slot on that too. Which one's the boot? Which one's the boot off of? The SD card? Does it pull a Raspberry Pi on you? I asked to make it native FreeBSD jail. I asked it to make a native FreeBSD jail over 4 days ago, and it's still churning at hand crank speeds. No. I could single step it faster. Oh no! My problem with it is that the performance naturally isn't quite there yet. No. But God, going for 4 days for a jail. I'm not sure I understand what goes into making a native for BSD jail. Call it the sci-fi scam 5 port. Oh. $15 laptop. A 15-year-old AMD 64 Lenovo laptop can do that task in 20 minutes. Whoa. I'm not sure if it's only the Chinese Debian's fault, the CPU itself, but it lags when moving a window. Ew. With a 5400 RPM speed. Was this thing going at like tape drive speeds or some shit? That's rough though. Waiting fucking 4 days for it to do a thing. $1,000. Whoa. Whoa. And that's just the board, right? I assume it comes with the RISC-V processor on it. But everything else you'd have to add yourself, like the SSD and the SD card and the video and all that kind of crap. This doesn't even have any onboard video, does it? Why can't you use the minimum maximums you just detected? Add a variance of like 10% to those detect the ones and zeros in the data in that way. I just haven't gotten that far yet, Captain Pie, which it's possible. I don't know. Just the board and shipping and taxes, etc., etc. And then the Samsung, yeah, no video, yeah. The Radeon card there does nothing. Zero. Fuck all. Nothing. You can't get any video out of it? No. Yeah, do you know how much of that is hardware issues and not how much is non-optimized software? I assume the video card being unresponsive would be lack of drivers, I guess. I don't know. That's just my assumption, honestly. Lack of drivers and bad drivers. Got it. Yep. Kind of expect it being a lot of software. Not even sure how optimized the kernel is for RISC-V. I can't expect it to be very optimized for RISC-V, because it hasn't really been hardware around for very long, right? Yeah, I'm assuming the compilers aren't fully optimizing for this hardware yet. Yeah. That's what that's what I would assume as well. There's been how many decades of optimizations for x86? So, for example, the onboard flash was a bitch to load. Took 4 to 5 reboots. And encouraged to get the fucking boot from the onboard flash. What? If anything, you'd think that would at least work consistently. Booting from the onboard flash. Huh? Because that would tell me that like there's something wrong with the hardware, right? At least I would think. If it can't consistently boot from something that's built into the freaking board. The issue was the kernel module needed to talk to the board flash. The kernel module needs to talk to the board to the onboard flash is crappy. Got it. Mine only boots will connect to external power up in the battery. What? Slendy Dev, how you doing? Never mind, boot. Doesn't even start. Doesn't power on. What? Is the circuitry that the power button's hooked up to only hooked up to the wall power and not tied into the battery power? How does that work? How do you fuck that up? Like, what? Even my dog shit netbook can do that. And the battery doesn't really last very long if it's not if it's not used for very long. If it's not used for a period of time. But still, if it's got charge, it'll fucking start. Had to buy a battery also. However, you need to flash up the firmware to get it to recognize the RTC clock. So that was another joy. It took 4 days just to get it to boot in a reliable way. Oh my god. More to the point, how do you fuck that up without noticing and fixing it before you ship it as a product, right? I was trying to turn it on, nothing. Thought it was out of battery, plugged it in, booted fine, said it charged 88%. What? I'm not a system moron. I can make things work generally. Yeah. Well, this is the sci-fi scam 5 board. Yeah. All right, gentlemen, thank you for being here. Appreciate it as always. You have a good night. Thank you for the follow. Appreciate that. Yeah. So that's one of the reasons why I haven't really touched Risk 5 yet, right? Oh my god. Dip switches. Dip switches. I haven't seen. Where are those on this board? I haven't seen those on modern hardware in a very long time. So did you have to do like trial and error with this? Wait. When the switches are up, that is actually a closed circuit and therefore on. So the switch is upside down. Wait, is it mislabeled? It booted from battery. Oh shit! I use a fleek multimeter to determine when the switch is closed. So yeah, this is mislabeled then, isn't it? That's even worse. What the shit? How do you fuck it up like that? What? The printing on the board and the switch are labeled wrong. Yeah. Yeah, so it's exactly inverted to what it says on both the switch housing and on the board. Silk screen. Are at least these labels right? MSL 0 through 3? Is at least that right? I guess there's nothing on this one. I guess that one's not connected. That's so bad. Oh my god. Excuse me. It's so bad. Anyway, that's yeah. So that's one of the reasons that I haven't really dove into Risk 5 stuff yet, is because nothing is really, I don't think, at the point for a non-kernel developer. Maybe, is that the right? Is that? Yeah. Streaming and for 2 days just fucking with the Switch. Oh my god. God damn. All right. But yeah, so it seems like these are ready for like kernel debugging, maybe. driver debugging and nothing else. Figuring out the drivers, and not really at OS level stuff yet, right? And optimizations there. That's what it sounds like. I don't know. Switch close can mean off depending on the system around it. When it's supposed to mean on, using a switch labeled the other way around is kind of bad. Yeah. Don't like the risk ISAs. They offer no power or speed benefits and only make debugging and low-level coding harder. Look, if you have a spare $500 million, we can fabricate a 9-nanometer board. I can get the first few $100 if you can get the other. $499,999,799. Give me another dollar. Yeah. What risk is good for, though, is education. What I see risk good for is the license around it. Atom is licensed. Atom is technically a RISC architecture. But in order to use it, you got to pay out a license to a company. Same thing with x86, right? You got to pay out a license to some company or collection thereof. Talk about RISC, not RISC-V. Oh, okay, yeah. Yeah. Whereas with RISC-V, it's an open ISA, which means you don't need to pay a royalty to anybody. Intel doesn't hand any license anymore. Intel doesn't give away any more licenses. No. Just to AMD, their direct competitor. I don't know. Then again, I suppose that they're using the AMD's extensions to x86 for x86 64, because Titanium went fucking nowhere. ZL? What is ZL? Risk is a systems architecture approach. That means Spark and IBM Power and the old HP PA RISC, now RISC-V and AAR64 are all RISC. Yeah. I want to get my hands on some Spark hardware. I've got some IBM Power hardware that I haven't turned on in a while, but, you know, I have it at least. Oh, it's an ARC. I'm developing with some buddies. Got it. We have AVX2 level of sim support. Okay. Some more than others. I don't remember where I was with this. So I need to take out my Spark, HPPA, and MIPS ARC rack lots again. All right, I need to scroll up again. What were the buckets for this shit again? 2, 4, and something else. What were they? 2, 3, and 4. Okay. Oops. God damn it. Half clock times 2 times 3 and times 4. Right? So B1 equals half clock samples times 2, 3, and 4. What am I trying to achieve with the buckets? Basically, this right here. Yeah, so a bit isn't at... It's the kitchen. No worries. A bit isn't always at a transition. So I can have 3 bits while the wave is high. 3 or 4 bits, right? Right here. So I can have more than 1 bit with the wave high. So I need to know the duration there. That duration will tell me how many bits and all that kind of shit. And I need to know the previous bit for some of this too. The buckets are for trying to figure out whether there's 2, 3, or 4 half-bit times between the current and previous peak. Yeah. When I change 2 buckets down the root partition on LVM, that's the one that I want to set up a fresh install onto. Whoa. Whoops. I need to I haven't reinstalled the system in a while, but I need to get more familiar with LVMs and not using the old school partitions directly, you know. When you know which bucket the current duration falls into, you can use that along with the value of the previous bit. Whether the next bit, use that to figure out whether the next bit is a 0 or a 1. Right. And then up to the next 2 bits, right? Yeah, up to the next 2 bits. Yeah. Yeah, if the gap is if it's in the first bucket and the last bit was a 1, we have a 1. If it's in the second bucket and the last bit is a 1, we got 2 zeros. Otherwise, if it's in the third bucket, I don't know if I really need to have that cutoff time, but whatever. It's a 0, then a 1. The first one I want to have a fresh install to it. Fresh installs across the board. Yeah. All right. So I want to print these out of the end here just for shits and giggles. B1, B1. Two and 3. 2 and 3. Well, we'll find out. We'll find out. Cannot use that as fuck you. 340. No, 347. Duration of samples, half clock samples. That is. Is that a float? Flow 64, it's fine. Cast out the integer here. I probably want to round up, don't I? Probably. Nine, 13, and 18. 9 seems really low for that. Yeah, let's round this up. Round float x float 64 int. And then I don't need to cast that if I'm dealing with just int. All right. If do I have? Hang on. Is there a round in the standard library that I could use? Actually, I don't want to do a seal. Seal returns the least integer value. Greater or yeah, sure. It returns a float 64. What the fuck you on about? No, I don't. It returns a float 64. I guess I could just cast it afterwards. I suppose. Guaranteed to have an integer value. Special cases are plus or minus 0. In part because an int might not be able to store that integer value. That's true, yeah. Yeah, because floor can go... Or floor. Float can have higher values than int. Larger values than int. That's the whole point of it. Return integer of math dot seal x. Do I have math? Nope. Yeah. These are usual hard workers to kick in. Both Pipewire and Wayland. I'm not on Wayland yet. I'm still on X. Xorg. The general use case anyway for users is probably not issue. Yeah, probably not. All right. Let's see what that gives me. My buckets. $10, $15, and $20. I don't know if that's what we want, is it? Was it peaks? Okay, I got the... Because 10 is right on the edge there. I rounded 4.7. Well, right. But I mean now specifically for the buckets, the bounds on the buckets. $10, $13. I mean, maybe. Are there any 11s in here? No, there's no 11s. Let's put the split halfway between each of these points. I'm not entirely sure how the buckets should work. Wouldn't it be more useful to use the maximum duration of the half clock rather than the minimum? This is neither the maximum minimum, it's the midpoint. So things which are closer to 10 than 15 go into one bucket, etc. Right. Midpoint of the minimum. We have the minimum. Half clock is minimum divided by 2, isn't it? Half clock is the that divided by 2, which is the lead-in cycle. which I think is peak to peak, right? The clock? Average divided by 2. Yeah. It's average, not minimum. It's average divided by 2. Because I'm taking, what, the last 20 peaks, I think? After skipping a punch. Gap. Yeah. Right here. Yeah, clock count and find deltas. So for each peak, I'm adding that to the deltas, right? I'm getting a total time for all those, and I'm just dividing those. Once I hit 20, I'm dividing that down to get the average for it. That's what this is. Half of that being the half clock. Right there. Then I get the number of samples average for that. And then I'm multiplying those to get the buckets. But let's be it's fine. It's fine. Honestly, re-explaining it a bunch helps me kind of understand what I'm doing as well. The average within the sampling period anyway. Yeah. Yeah, which if it varies too much outside of that sampling period, will kind of SOL, but at least it'll reset itself kind of at the beginning of each lead-in. At least it should. Well, I don't think I have it doing that right now, because I don't clear that out here at the page found like I should. As I say, as I'm looking at find clock. Oh right, yeah, but I don't reassign clock duration here in all this stuff. I don't think. Yeah, because that's only at from the first lead-in, not all of them. Using either minimum or maximum would be kind of risky since you're looking for things being close to several multiples of it. Yeah. For up to 4 cycles, it shouldn't clash too much. Something like that. And 4 should be the maximum, I think, right? Yeah. You know, let me assign these as not there, in here. And then I can have a function that's like, hey, what bucket is this one in? Now I can do a switch statement over that. Use the maximum. If you're unlucky, you could end up with a size times 3 being closer than size times 4, when it should be 4, just because it slowed down since you measured it. Yeah. Okay. Which bucket? Delta. And I want that to return bucket. Bucket 1. Bucket 2. Bucket 3. This MFM stuff is definitely something I would need several whiteboards for to think through and understand how shit works. Yeah, and that's kind of like what I'm doing here, right? Is I'm, all right, well, what happens if I do this? Does this mean anything to me? I don't know. So that's basically the stream is me figuring out what the fuck MFM is and how it works, kind of, right? And finding the stuff that doesn't work and why doesn't it work, and okay, this is why it doesn't work. Yeah. Yeah. Sure, they're unlikely to be a problem in practice given reasonable sample rates. They're not being too much wow on the tape, but still. I do have a tape somewhere that has some pretty extreme distortion on it. I later found out that this tape I already have decoded because I have another recording of it. What the hell is it? Did I close out the window? I closed out the window, didn't I? Let me pull that up real quick, and I'll show you what it looks like. Study box. This one? Yeah, this guy. This guy has some pretty terrible distortion on it. Look at that. Yeah, listen to how this sounds. Let me split this real quick. And solo it. Listen to this. Someone's screwing with the knobs while it's playing. It's so bad. So bad. Yeah, it's nasty. And then it clears up right there. That sense. What the fuck is going on? Yeah, so someone's like, whoever recorded this was like screwing with the volume as they were recording it to try and, I guess, get levels correct or something. I don't know. But it's so bad. Look at that! Look at that! You can see it going across the spectrum. Yeah, I'd be curious if this is like recoverable. Not that I need the data at all, because I like I said, I already have this tape decoded. But it's not just the volume either, though. It also stretches. Yeah, it's stretching a little bit in there. Yeah. Actually, we can actually see that in the spectrogram here. Right there with the wavy bit. Can I? That. Just low pass, it'll be fine, damn. Yeah, I don't know about that. When it goes, like someone just putting their finger on one of the tape spools, you know, while it's going through. Oh, the tape drive getting warmed up. The rubber's a little stiff in the belt or some shit. I don't know. But yeah, so this is the worst one I've seen. I don't have any of them that are worse than this. And then it clears up for the rest of it. You know, I'm curious actually what if it can. I'm curious what happens when I throw this at it. There it is. Copy that. So just for shits and giggles, we're gonna throw this file at it. This is Terry Ness study box. Undefined. Oh shit. 365. Oh, oops, I forgot to uncomment, or I forgot to comment this one out. Are you done? That's finding some of it. I'm getting past the crap. And it's wow, okay. Those are more or less the same. I wonder if I should be able to decode this. That'd be hilarious. Whoa. Whoa, that's a little far off. 26 seconds in. Go away. Oh, I still delete him though. It's below the threshold, isn't it? So it's finding a new. Yeah, it's finding a new. It's seeing the gap. It's seeing a gap there. Because it pops below and above the threshold there. Huh. Well, we're not going to be using this one to try and like, you know, get our shit working. We're gonna be using the good recording. Let's start this back up. All right. Yeah. Okay. So let's. Then try to get the yeah. Bucket 1, 2, 3. So this is. Three and then 4. Okay, so so I want to take the delta and subtract that from all of the bucket midpoints and find the lowest one, right? So then I'll know which bucket it's in. In theory, right? D dot B1 minus delta. I want the absolute of that though. B2. And let's get 3. If B1 is less than B2 and B1 is less than B3, return bucket 1. If B2 is less than B1 and B2 is less than B3, bucket 2. If B3, do I need to like panic here? Is less than B1 and B3 is less than B2. Return bucket 3. Bucket unknown. Who knows what bucket? Okay. So. Here. What did I call that function? Which bucket? Which bucket? Sample delta. D. Okay. Case bucket 1. Case bucket 2. Why can I not type? Bucket 3. Not the type there. Okay. If last bit d dot last bit is 1, add bit 1. Else last bit is 0, add d dot add bit 0. If d dot last bit is 1, again, d dot add bit 0 twice. Else add bit 1. And this is the whole data started stuff I gotta do. The 0 counter and crap. We'll come back to that. If d dot last bit equals 1, d dot add 0 and then a 1. Else panic. Do I return an error from this? I do. For every last bit one, in case you need to reset the counter as well. You know what? Let me invert this switch a little bit. Let me do this. Bucket 2, bucket 3. Default. Yoink. Paste. Got that. Else. Yoink. Paste. I'm 307. 307? On their code? Yeah. Yeah, I know. Yeah. Yeah, I was just inverting this first, so it's less nested, maybe, kind of, sort of. I don't know. Add bit instead of add for the bucket 3 cases. No. I don't actually have an add bit, do I? Yeah, I don't actually have an add bit, so it should just be add. Yeah, it's just add. So the other way around there, but yeah. Okay. Get rid of all that. Then here, there counts that. Wait, what? What am I waiting for? Hmm. Last bit equals 0 parts yet? Know that. Man, why is my... My fans are going like crazy. I don't know why. Had him in the code, I deleted it. Well, I didn't have much though. Well, hang on, let me. Okay, yeah. So for last bit of 0. Like that. Bucket 1. Add bit 0. If not data started. Is it data started? Yeah, data started. Okay. Track lead in and start length. So I installed the real OS, so I installed Chrome OS. What? Ew. Welcome, by the way, Def Can Game. How you doing? Back there. If data 0 count is 1. Did I save lead in something? Had the lead in crap somewhere? Or do I have it up here? Oh, this is for yeah, this is for the saving the actual data out. Lead in start is I. Yeah. Oh god, this dude is part of fucking Chromebook. Can't they install normal Linux OS? Yeah, that one. That one. Okay, so that's this bucket here. Next, we'll do this one. Data add 1, add in a 1. If not data data started. We didn't start any data. And if the 0 count is greater than 10, arbitrary number, but it works. New data track. And data start equals I. Oh, if data start is 0. Like that. And data expect 0. Zore? True. And data current. Like that. They're nice and constant, but shit always doesn't work on them. Yeah. Do you mess with them at work since there are loaner guest mode devices? Ooh. For students. Oh, God. Yep. To take online tests in classrooms that aren't computer labs. So it's interesting they have an option to enable Linux tools, but yeah, I hate them. All right. If this is the first one bit we find, the next bit should be 0, and then the first byte starts. Yeah. Okay. All right. Now let's see for bucket 3. Should not be possible after a 0 value. Okay. Whoa, nope. If data started. Data started. We fail. At that. No, that is going to be a delta. Delta. Okay. Add bit undefined. Son of a bitch. Guys just spending $250,000 on laptops. It's used maybe 10 times a year. Delta too large after 0 at 18. That ain't right. I'm gonna go ahead and print out the data just for. I don't have any data. Well, yes, I do. Shits and giggles. What did we find before this? Anything? We did find some stuff. Okay. There's some lead in, but it's followed by a 97. That doesn't seem right. 197. Should have been a 1. T450s with mint. Ooh. I'd use a Debian with some custom wrote exam software. Honestly, for me, it's black magic, but as long as I don't have to touch that shit, I'm happy. Some Python crap. Oh, God. Did you not initialize stuff correctly for skipping the lead-in? Probably not. Probably not. Probably all broke. I need to hit the bathroom, though. I'll be right back. I'm going anywhere. heck? Yeah, the lead is supposed to end with a 1, not a 197. Off by a little bit. No. My current place is Ubuntu only. I'm pretty sure there's a lot of numbers on the right. That might mean something. It might, maybe. I do imagine it's welcome. Feels gonna have grades with ThinkPads. One crate being worth upwards of $8,000. Still may a few, yeah. Yeah, so what happens when he uses that as one of the bits for the next byte instead of starting data on the next bit. Oh, that's, yeah, well, hang on, I clear out, where is that? Right here. Current byte is my data current. Data started right here. Expect 0. True. Also indicates that by having all those zeros as data instead of being skipped with lead in. Oh, I don't think I do the data started stuff correctly. Or at all. Somewhere. Like in his ad, I think he's got this. Do I even check that in my ad? I don't check that in my ad. Okay, if not data started, return. Zero bit before each data byte in the study box encoding? Yeah. Yeah. Have you considered writing this in COBOL? Fuck no. Undefined data start. What the? Oh, because. Or is it 0 bit before and after? No, just before. I think. Oh! Okay. So that trimmed out all of the lead in. Okay. All right. So there's that. Oh, yes, this gives the RQ handler time to shut off and restart the MFM decoder. Oh, so there is. It's a 0 bit between each pair of bytes, arguably. With PLB. There we go, hardcore PLB. I've got an issue at work that's this PLB bullshit. Yeah, I gotta get that out in hex in a little bit here. That's my next step here, just so I can read that a little bit easier. This is one shit bank that thinks they're the hot shit and our most important customer. Surprised they're not. Spoilers, they're not. Excuse me. Yeah, they were pissed off that I didn't like drop everything and start working on a thing. I'm like, well, fuck you. That's why. You're not our only customer, so go to hell. Yes, so there's some custom programming that they want to do, and they're passing data in places that we haven't accepted data in before, at least not that kind of data. So I've got to like jump through some fucking hoops to. This detail line's on a remit on a check, right? There's also a total line that they want. Fine. But this total line is parsed out differently because fuck you. It's pipe separated. Go to hell. But that extra field comes in like before all the data lines. So if I wanted actually to print after the data lines, I gotta pull some bullshit shenanigans to print it in the correct spot. It's being a bitch, and I gotta write like shit out to disk to read it in later. It's a whole fucking to-do. It's a pain in the ass. Page number header, delay packet, yeah. C5 is 197, yes, so that is probably correct then. Okay. I still want a, I still want that data printed better. Where is that? This here, okay. Func, hex bytes. The right kind of byte, Jesus. Out, make string length of in. I be in range in. Out at I equals format.s printf. C5 01 01 01 01 00 C5 C5 05 05. Ah! So that looks kind of correct, actually. It kind of looks correct. Ah! All right, so that delta too large. I don't like that. After a 0. Can I get the Can I split this? I split it for 4. I want to split 1 though. One here. Where the hell is that? Ness go study block. Is it in here? SBUtil. What are the missing command? Yeah, okay. Fuck you. Like unpack. Yeah, unpack. Nope, wrong one. There it is. Okay. Header 0 right there. Checksum C5. That's that C5 there. And the next C5 is a delay. 56, checksum C5. That's that right there. That checksum, right? Maybe? No. Or is the delay always C5? Delay might always be C5. C5 05. Okay, yeah. Mark data end. delay. Okay. End of the delay. Checksum C0. Okay. Does that go to the A4 there? Work RAM load bank 01. Address. There's a 6K. Checksum A4. Okay, and that's not the that doesn't have the what's it? What's the checksum? A4? I'm not seeing that in here actually. I'm seeing 1A. I'm not seeing A4 though. Like 30. A delay. The computer C5 checks someone, then stop something. Right, and when it detects a C5 line, the C5 detects a C5. The checksum is correct for that first byte for the next packet. You see an A4? I'm blind then. It should be after this stuff here. It should be after that, because this is telling it where to go, I think, right? That ends on C4, I think? No, that needs to end on A4. Third line in the middle. Oh, right there. Oh, is the checksum the first bit of it? No, that's... I don't think so. Did I get misaligned here for the shit? A4. The next one is DB. DB's there. Length of 30. So that's sure, probably. Yeah, I think I missed a packet addition. Yeah, okay. C502, C7. Check some C7, and okay, C502. 0002, and then C7. That's the checksum there. C5. 0505. Ah! Then it marks the end of that, and then another one? End delay, and then another delay. So that end delay is probably that little blip we're seeing before the gaps. Right? And delay there. Mark data start. C505, that's the end. C5 030320 Okay, so that's the name table address. Checksum 97. That's that entire packet. And the next packet, C5 8007. 928. That's probably the 80 then there, right? Yeah. Checksum 10. There. Yeah, so it's crapping out in the middle of the data, isn't it? Also, I'm getting like halfway through this page, this chunk. God damn. Okay. Don't I have the raw data here? Name table choose no. Those numbers correspond with anything packet? Nope. Oh, that's the raw packet data. Script data, whatever. Oh, what is this? Like the freaking offsets? That doesn't really help me line it up to this. What is this? Oh, yeah. Okay, so that's name table data. It's going to be part of this here. Stop it. Give me, thank you. Open terminal here. It's gonna be in here somewhere. Can I not? Thank you. Okay, so we're getting that far. It's crapping right there. Right there. It's not getting to that 5A. Huh. If I had to guess, it's probably that your clock recovery is rather limited. I'm not actually doing any recovery. So the 18 is probably just barely too long to go into the correct bucket. Yeah. Yeah. What are my bucket cutoffs again? Let me... oh, that's... okay, I don't need... So this I've basically re-added, recoded again. So I don't need any of this anymore. Sample delta less than 6. Do I have that in there somewhere? I don't know. Give me this here. Yoink that. I want to see that there. The averaging of the leading peaks is the clock recovery, right? But that only happens at the beginning of the page, and we've already only had that once. Right. But I'm not doing that continuously. I'm just doing that once at the beginning of the chunk, and going from there, right? Limited, yeah, okay, fair. Yeah. And that's right at the boundary, too. Should I have those as floats? B1 through 3? I don't know. Do I need to add extra resolution to that? Where are those set up? Up here with the half clock samples. I'm rounding those. Let's try not rounding them and see what happens. See if I can... I gotta make these floats. And then in the which bucket, this guy here. Can I do that math there? Well, the absolute, I was really probably yell on that, actually. Let's see. Yep, invalid operation. Measurement size float in N64. Let's... Cannot use that. Type info. God damn it. 251. What? Huh? Oh, an app. Oh, Jesus. Shit. Float 62. No. Oh. There you get by. Yeah, my round is using seal. It's not really round. It's more of seal, but whatever, it's fine. And I want abs F. That got past it. Unknown bucket of 16. What? Okay. Where was that panic again? 4, 2, 5. Here, unknown bucket. Last bit is 1. How? Sample delta is that. Yeah, I know. I don't care. Okay, so it's getting down here somehow. Unknown bucket. Delta is B1. Percent 0. Percent 0.03 F. Sure. Like paste 2 3 new line there. New line. Let's add 2 spaces on each. Whoops, on each of these. Because then here I'm doing D.B1 dot 033F. Two and then 3. Okay. All right. Delta B1, B2, B3, D dot. All right, that's yoink and paste, D dot, D dot, D dot. Let him reinvent the wheel. It's fine. Oh, come on. Those are integers. Yeah, those are integers. %D. Did I at least line them up right? No. I don't like these lined up. Shut up. 6. Close enough, whatever. Okay, the distance on bucket 1 is 6, and the distance on 2 and 3 are 2. Delta is 16. 13 and 18. So it's right in the middle of them. God damn it. Do I want to floor that? Before I absolute it? After I absolute it? Whatever. No, that didn't help. If there are floats, this would have been less likely to happen. Because I was using the integer function before. Not .2D, it's .2F. Should be 0.2F, whatever, it's fine. .3. Yeah, now that you mentioned the floor won't really help. Because I want to... Ah! Ah! I want to... Ah! We're getting a lot further now, which is cool, I guess. Quite a bit further. We're getting down to 27 minutes, 14 seconds. Hang on. Not the shit one. No. Okay, it's breaking on the very last page. Is it breaking way over here? Hang on, because that data is garbage, it looks like. Is it breaking here? Let me get the break at that. Let me print out the right here at the delta to duration. That's what I want. D dot delta to duration I. All right. What is the time code at where it craps out? Because this might be after everything else is decoded. 28 minutes and 1 second. It's after everything else is decoded. It's crapping out right there. Trap exit, how you doing? Okay, it's crapping out at crap data. Yeah. Shit. All right. So I don't want to panic there. I just want to ignore it. Maybe a waveform? Okay, yeah. Let's have a look at waveform. Ah, shit. Where was it? Oh, God. Spectrum. Close enough. Zoom. And then waveform. And then let's zoom again and again. More. More. Enhance. 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 No, so this is at the very end of the tape. So this is just crap. Yeah, like this is the end of the tape, right? I did detect and ignore, yeah. Doesn't look particularly crappy at this scale, right? It's because it's some blips in there, you know. And so it's across all the frequencies too, you know. Well, this right here might be some data though. That right there is possibly data. This little bit. Yeah, there's some data. That's probably the end of delay. That's probably what that is. We can't assume that won't happen in the middle of a tape. Yeah. Yeah. But that got surprisingly far with the decoding, actually. Local Long Q. Local Long. Is that right? How you doing? Welcome. Welcome. How you doing? Yeah. By the way, for everyone just coming in, I'm working on some audio decoding. Probably just keep this off the fucking thing. For this thing. This might be something. This might be why he sometimes applies filtering. Probably, yeah. I might see if just adding a filter for everything helps at all. I don't know though. We'll see. Like across the board without before even trying to process the bytes, or the bits. Excuse me. But yes, this is a little edutainment device or education entertainment thing for the Famicom. It's got it uses a tape drive. On one channel is recorded audio, and the other is data. The top over here is the recorded audio. So if we hit play on this,
言えるようになるのよ。頑張ろうね。
and the data sounds kind of like this. Well, that's a delay, but the data, where's actually some start data. The data sounds a little bit more like this. Lead in. There's the data. There's the actual data. And we actually decoded a good, the majority of this tape actually. Well, I mean, I say decoded into a raw byte stream. I need to get that into like a ROM format. I'm sorry, the ROM format, to make sure that it decodes correctly to the format and it loads up in the emulator. We'll get there eventually, but maybe not tonight. We're already running a little late, or a little long today, so I don't think I'll get that far today. But I want to be able to also do the reverse of this: is take the ROM and re-encode that in a waveform, so I could record it to tape and play it on hardware. Once I get that working, it's only a few more steps to get homebrew on this. Yeah. Which would be fun. Personally, I prefer to be robust enough to not require filtering, but whatever works. Yeah. Well, I mean, so if I look at the spectrogram again, right? Let me zoom into that. So this is English 1, so it doesn't actually repeat a lot across the spectrums. But if I open up another one, I think 12 was the other one I was looking at. What the hell is it? ROMs, and then English, and then 12. That's not the file I want to double click on. I don't care. I wanted the raw tapes, 12. In theory. Yeah. So let's split that. That's not what I wanted to do. Well, you can see it here, but split. This one can just stay as waveform. So this one has the frequencies like mirrored a bit more up higher, right? In practice, we've already tried to get homebrew running on it once, right? We tried. I need to I want to get to the point where I can try again and understand more of the process for getting there, right? Yeah. So this looks like it's got 1, 2, 3-ish copies of the data. This on the different, frequencies. Whereas this one's only got 2.5, maybe. So can I just cut out everything above 5K? Right, 5K, about 5K, and have good data. Did I see MP3 file extension there? Maybe, I don't know. AUP3, OP3. That's the Audacity whatever. In 600 megabytes for this this file. Aren't these zip files or some shit? I thought they're zip files. Hex dump. CV English 12.op. No, there's SQLite? Okay, Jesus. All right, I wasn't expecting that. It's a fucking SQLite database. All right, okay. Oh. Anyway, completely off topic. Oh, good. Saturday. What's you doing Saturday? Doing sure, that randomizer with some friends. Ooh, several randomize several different games into each other. So you can have players playing different games and finding items for each other. And the current plan is me playing Factorio and the others playing Ocarina of Time and other shit. What the fuck? So you'll find something in Factorio that will unlock something in another game? The data rate is at about 4.8 kilohertz. You don't want to cut too sharply. Right. Well, yeah, so about like above 5K-ish. You'll research their items. That's hilarious. What? And they will find text-free... Hey, can someone find plastic processing for me? I'd really, you know... I kind of need that. Or rather, what text do you start with? Do you start with any text? Hey guys, can you find red science for me? I'd appreciate it. Nothing below about 10K. Really? All right. We'll see on Tuesday. Oh. Yeah, I suspect that has something to do with why source code breaks. Actually, can I do? Hang on, effects. Filter QVQ, graphic EQ, curve EQ. What? Okay, fine. Select everything. Effect, curve EQ. Preview. That's just gonna cut everything off, isn't it? Yeah. Wait, this is okay, yeah, I want 0 to what, 10K? Wait, what? Huh? How does this work? Oh. And then nothing after that. Preview. I don't know what the preview did. Do it anyway. See what happens. Separate 2 times the data rate? Yeah. That didn't change this like I thought it would. What's it sound like? Still the same. Hold up. If I do the same thing here, generate, no, effect, curve, yeah, same thing. Same exact thing. I'm going to export this as wave. Filtered. Just for shits and giggles, I want to see if the other decoder can do this. Hang on. English 01. Filtered. Nope, aired out. Gap too large. Gap too large? Wait a minute. Hmm, 44.1. Huh. What happens if I throw my code at it? I'm just curious now. It dies faster. Delta too large after 0 at there. Huh. It does get some of it, though, which is interesting. Yeah, because without the filtered... Actually, didn't I, like, re-record this as well? V2. Oh, yeah, that's what I'm working with now, I think. Is it? Raw tapes. No, it's not. I don't have that open. V2. Yeah. Is this one. Pretty messy. We got the hang on, let me split this real quick. Split. And let me pause this. If I just play this one, you can actually hear just barely the bleed through of the recorded audio. Yeah. It's the only place it'll happen. You'll hear that channel bleed. Yeah. Because everywhere else there's audio, there's data playing. This audio is special in that it is it's put on the tape, so you can pop the tape into a tape player, hit play, and figure out which tape it is, right? Without having your ears bleed. Everywhere else, it has the what's it? The data on there. All right, so let's actually take that filter, not that one. Well, yeah, graphic EQ. Now, give me the curve EQ. Let's move this up a little bit to 14. Yeah. 14, have it drop off pretty sharp. Oh, that doesn't look terrible. What's it sound like? Not terrible. File export as WAV. V2. Oh. Filtered. Hertz? I don't think so. Hang on. Let me go back in and check. I think it was 10. I don't think I chopped it off that hard, did I? The whole thing. Effect curve. Oh shit, yeah, I did. I did chop it off that hard. Yeah, 10K's up here. 10K's there. So let's Control Z on that. Effect. Curve. 10K is way up there. So let's go a little above 10K in at 10K. Now. Lopta, how you doing? LFM on MFM on tape? Yes. Okay, there we go. So now we've got a hard cutoff right above 10K. All right. There we go. Yeah, it's study box tapes. Sounds kind of like this. File, export as WAV. Save, yes, overwrite. Okay, okay. All right. Let's need to filtered. Delta too large after 0. Huh. That, what's the, where is that? Too large after 0. That's just going to be a string of d dot delta. Oh, it's at 19 seconds. Hang on. It's right there. It's right above it. 19 seconds. What's that 19 seconds? This. What? It's picking up that shit. It's picking up the fucking speech bleed as tape data. Huh? Oh, now I see that. Yeah, okay. Is it because it's so noisy here that it doesn't pick it up? What's the amplitude on this stuff? Zoom into that. Zoom into that. Yeah, the amplitude is like nothing. How is it picking this up? There's nothing there. What did I say? 19 seconds? 19 dot something? 19.33. Oh, I'm looking at the wrong file for that time code. 19.33. This shit right in here. That. It's picking up this shit. Fucking how? Oh, this is after filtering? Oh, it's the, yeah, it's the V2 filtered. All right. Okay, so let's just filter this. Effect Filter. Okay. That doesn't really change it much. Just chops off a bunch of it up top. I don't know. An amplitude filter then. Isn't that kind of what I'm doing with... No, not that. This one. With the peak stuff? Right here. Isn't that what this is? The amplitude? That's at a amplitude of 500, whatever that equates to. I don't know what that actually equates to. Do I need to increase that? The waveform didn't change either. It would change very slightly. Barely anything. Barely anything. I can see a little bit of variation here, but a pixel here and there, a pixel in either direction, kind of, you know? A little variation there. So do I need like a gate? It's roughly 1.5% of the max volume. All right. So what happens if I double that? It's even worse. 19.05. Okay, it's still crapping out in there. Too high. Oh. Yeah, I need some like actual proper filtering or something. Wait, how is it getting data at 19 seconds in? There's no data there. How is it getting C50101? How? That shouldn't exist yet. What? Huh? I'm looking at the filter one, right? Yeah. What the shit? This guy here. It's finding it in there. Huh? I don't know how it's finding that data though. Like that fucking what? What the fuck? Also, the fact that this only has one audio channel. God damn it. No. It's something stupider. Something stupider! It's expecting 2 audio channels. It's hard-coded to expect stereo. It's getting every other sample. It's getting every other sample because it's a mono file. If go audio WAV, give me that. Decoder, read metadata. That's not what I want. It's in format, isn't it? Format.num channels. Return nil nil format.error f. WAV is not a stereo file. Not a stereo file. One channel means that all our timestamps are off by a factor of 2. That is correct. Yup. So I'm gonna assume that the other one I was looking at, this one, same issue. Same issue. That's why the filtering didn't work. Part of the why it didn't work. It's because it only exported one. Okay. Why did it drop out there? What the hell? I don't know. 38. Not yeah. Which was the start of the data? That was the start of the data. This is 30 roughly seconds. This is the This is the other one. No, don't save that. God damn it. Over here somewhere. 38-ish. About there. Yeah. Yeah. It does make a bit more sense, doesn't it? Yeah. Can I join? How do I join these? Make stereo track. There you go. Okay. That's how I join them. So I need to do that before I export it. Because I don't think I can like filter only. Yeah. If to filter the channels independently, I got to split them and then rejoin them later. God damn it. And half the samples also means much less breathing room between buckets, much more likely to run into trouble. Yeah. Which is why... Yeah, B1, 5, 7, and 10 versus what were we working with before? The low one was 10, wasn't it? Yeah, 9, 13, and 8. Which was better. Yeah, 9, 13, 8. Roughly 10, 13, 8. Yeah. Yeah. Half the size for each bucket. Yeah. 5, 7, and 10. God damn it. All right, so let's not do the filtered one. Let's just work on V2. V2 is just the one I recorded more recently, like this past week. V1 is the one I recorded in January. Okay, there you go. 10, 15, 20. It's about right. Delta 2 large after 0. 56. That's way out there. A minute 34? The fuck? That's over here. Somewhere. No, it's not there. No, stop. It's over here somewhere. How am I going backwards now? What the fuck? I don't know. What time is it? Almost 8 o'clock. Yeah, I think I'll actually wrap up. I got pretty far. I got further than I thought I would get, honestly, tonight. We've got almost an entire tape decoding. Well, decoding into a bit stream. Yeah, the data's probably fucking right. I don't know. I don't know if I'll be able to really test that very too much until I decode it into the packets, and then compare that with something that has already been decoded, or decode it into a StudyBox file essentially, and then diff the StudyBox files, kind of sorta. I'd have to unpack and then diff, but I'm saying because I don't want to diff the recorded audio, because that would come up with differences no matter what, pretty much. Yeah, I got all of the data bytes. The actual data bytes was quite good. Yeah, I didn't think I'd get that far. Yeah, I thought I would have a lot more trouble with getting good data bytes. Good bytes, honestly. I thought I would have a lot more trouble with that. But then again, I don't know if these are necessarily good. These might not be good. We'll find out eventually. I mean, it's good enough that I can compare that to unpacked data by eye anyway. I can eye the unpacked data and it matches up. It's good enough for that. Yeah, I'll probably do some housekeeping work on this this coming week. At the very least, like write out the raw data the raw data packets, or the raw data pages anyway, to disk somewhere so I can inspect them later. Because as it stands, I'm only throwing data at the screen at the terminal. If something goes wrong, so all the pages before that are just discarded. Yeah. Given how jank my original decoding setup was, I'm not surprised that you got to bytes. Is each channel 16-bit linear? I think so. I think it's linear. But it's signed 16-bit. Little Endian. Yeah, that's what it currently is. Yeah. Currently working with oh, that's another thing I just noticed. The sample rate's way off, or not way off, way different in this one. Huh. I don't know if that has anything to do with it. Actually, that would change the bucket sizes. Where's my console? This is V2. All right, what are the bucket sizes on one again? Without the V2? 10, 15, 20. And then this one is, what is it here? 9, 13, 18. Okay, so it is changing the bucket sizes, and is it breaking at the same spot? Diedrich, how you doing? So that's 28 minutes. Where's this one break? Roughly same spot? 28 minutes in? A minute in? No. Oh boy. So I got a bit more work to do with that. Yeah. How many hertz are you running on your sine wave? What? Gotta go. My son wants his computer back. No worries. You have a good night. I'm not gonna be around much longer, but thanks for stopping by. I appreciate it. Yeah. So this. Yeah. So the sample rate that I'm working at is working on. The one that failed right now. That one was 48 kilohertz. The other one that fails at 28 minutes in. That one is 44.1 kilohertz. Basically, for the square wave, it's supposed to be about 48 hertz, 4.8 kilohertz. Yeah, roughly about that. Yep. But yeah, so I'm pretty low. Deep bass frequency? Nah, not quite. Sounds like screeching, honestly. Go back over to here, and then let's go ahead and split this. Split the mono, solo that. Not like this. That's the data I'm decoding. This one is dying over here somewhere. Dying over there. For some reason. Yeah, I suspect I gotta tune it or at least send it through a filter or two. Yeah. It's not low. Midday is 440. You know. As you can hear, the wave is modulated. Yeah, it's used for data storage. Yeah. But yeah, so the original code only does old network equipment, kind of. It'd be closer to like the raw data, the raw like waveform data off of a floppy drive or a hard drive before it's decoded into binary. It sounds like old network equipment for good reason. It's phase shift key. Yeah. Hey, well, appreciate that. Pretty much a modem, yeah, just one way. I guess, yeah. But what was I saying? I don't know what I was saying anymore. Oh yeah, so the other decoder, the one that I'm basically porting more or less to Go, using that as my learning project of figuring out MFM and how it works and how to decode it, and eventually how to encode it. The original code only handled 44.1 kilohertz audio, and isn't as forgiving with the input data. I want to see if I can make something a bit more robust and a bit more what's the word? Lenient? That doesn't sound right. It sounds like a fairly early modem. Not so bad as to be FSK, but maybe 9600 baud, maybe a touch slower. Yeah. But yeah, so I want mine to be to be able to handle crap audio a little bit better, I guess. Because with Sour's code, it'll just it'll try to a certain point, but then it'll crap out on data that works on hardware that I've verified that works on hardware. So it could be a little better, and that's what we're trying to do. And it's a big learning experience, and half that learning experience, or in building up that knowledge, I want to be able to use that to reverse the process, so I can get homebrew on this. I want to get homebrew on this. So that the first homebrew project that I can think of, it's dead simple. So it'd be something really, really straightforward. I might already have the image already for this. Yeah, I've already got the missile worked out. The graphics. So So I wanna have the missile knows where it is because it knows where it isn't, and then like it'll be like a still image, right? That'll be the hello world essentially of the homebrew. Getting this on the study box, which I think will be hilarious. But yeah, I got a little ways to go for this, to get that anywhere. But I don't know. Eventually, eventually I'll get there. Yeah, I don't know. Anyway, I'm getting hungry, so I need to wrap up. Because meme, exactly. Well, so it'll demonstrate a bunch of stuff, right? Getting the name table data where it needs to go. Getting the character data where it needs to go, right? A script to control like timing and shit. Getting the audio on that to make sure that start and ends where it's supposed to. Maybe get the repeat thing at the very end of it. There's still the option of trying to recreate our first test tapes, but working. That's true. Is that the Ace tapes? Those ones, or are there other ones that I'm not remembering? But yeah, getting this working will. In order to get this working, I have to have a lot more solid groundwork for a bunch of systems on the thing. A bunch of different pieces that aren't exactly in place yet. It's a Doppler radar almost. So, have you not seen the video? Not seen the, where's the... The missile knows where it is. This right here. Ah! Mostly Maxie, how you doing? I'll play that in a second. Hello, how you guys doing? Today we're figuring out MFM or modified frequency modulation encoding on tape. So it's for this guy. I keep putting it back in the. It's for this guy right here. It's a study box. It's a Famicom. I hesitate to call it a cartridge. It's a edutainment kind of system, right? Education, entertainment thing for teaching English to Japanese school children. Yeah. I'll fire up one of the tapes here. Enjoy English. This one here. 8-track tape. No, it's only 2 tracks. It's got data and recorded audio. So this is... No, I won't do it on hardware. This is running in an emulator. But that audio would actually come out of the Famicom. Dual-sided, right? Question and an idea. Hello. How you doing? Samuel. Am I saying that right? Edutainment, yeah. What were you working on stream? Max Waters, how you doing? Hello. But yeah, so it's like you follow along with the workbook. And this one is like, hello, my name is... That's Johnny over there. This system is so jank, by the way. The animations are jank as hell. So you see artifacts all the time. Cursed Rust encoding. Rust coding, okay. Oh. I've been having some ideas for creating a game. Oh, okay. Commercial music from the 80s. This is very early 90s. I think around 93?
Hello.
92, 93?
Hello.
Hello.
I'm Akira.
Yeah, so it's this stuff.
I'm Akira.
Yeah.
What's your name?
And we're doing some, not really
What's
reverse
your
engineering
name?
right now. It's more of decoding.
I'm Arnie.
Because this portion of it, we've already
I'm Arnie.
figured out how it works.
It's
I mean, that's
nice
how we have the
to
ROM.
meet you.
Um,
It's nice to meet you.
turn that down a little bit.
Oh, it's nice to meet
But
you.
I want to be able to go the other direction. I want to be able to encode stuff so I can have homebrew essentially on this thing. I'm pointing over here because that's what my Famicom is. So I can have homebrew on this. And just as you guys are coming in, I was so basically a 4086. Not quite. This is a 6502. But yeah, so the Hello World homebrew, whatever the hell, is basically taking this video and putting it on the Famicom. I've already got the graphics figured out for it. Oh yeah, to be clear, the flickering you see is not an emulation issue. It happens on hardware. Now, this is how jank the system is. Oh yeah, it's so bad. I don't know much of coding and creating the game itself. I don't know how the market of games works. That's kind of how I got into like this shit that I'm doing now. Honestly, originally I wanted to reverse engineer games to figure out exploits to use in tool assisted speedruns, which is very narrow and I want to do that. Okay, sure, fine. So I started to figure that stuff out. Open up a game in an emulator, go in the debugger. That's assembly. I don't know what the hell that is. So I read an assembly book from the 70s. And I went, neat. I can read this now. Load a thing there. Add a number. Save it there. How does that make a game? How does that work? And then I went down a rabbit hole of figuring out how games work and how to program it on the NES. And then eventually the developer of this emulator here was not really ranting, but like what's the word? He was saying on Discord, in the NES Dev Discord, that he was tired of people like asking him to get random Chinese bootlegs working, right? Because those are no fun. It's just some random shit for the mapper. I want someone to figure out how the study box works. And I go, what's that? There was one on eBay. So I bought it. And then with some help from a Bridgewater, we all figured out how these worked. And we got it emulated. Procrastination, yeah. Nobody cared about a refresh rate back in the day. It was hard just to get equipment. It's not a refresh rate thing. So the NES, or Famicom, runs at 60.1 whatever FPS, period. The games, not necessarily. There's games that run at like 30 FPS or whatever. The hardware runs at 60. The software can run slower. The reason you see the flickering in the ROM here is because there were two separate meta sprites on screen. There was a lot of sprites on screen, and to animate them, it takes the current sprite, moves it entirely off screen, and then moves it back with the new position and the new tiles. So sometimes it doesn't always finish by the time the frame is ready, right? So you'll see so it's like certain characters like chopped in half sometimes. Thing is, I want to create a realistic game, like an actual police simulator where you'd be part of various police operations, pursuits, etc. Yeah, have you seen Thor's site about developing games? Yeah, have a look at that. It goes through a lot of stuff that's needed for making games, including tools, skills, etc. You may think you need. Right. Now, YouTube does help a lot. Doesn't help. I don't find much help in YouTube tutorials in general, regardless of what it is. Like a tutorial, like teaching you how to do a thing. The more help I find with out of YouTube videos is more of like a higher level kind of aspect to things. Yeah. More of reading docs again and again in person. Yeah, for me, yeah. I like to read the documentation. I don't like watching a video that someone else read the documentation. Just let me read it. I'll be happy. God, there's this one thing at work. Oh my God. So there's a piece of software that my boss wants to bring it. So a little bit of background. I work at a print and mail shop. Our customers are banks. We print checks and mail them out. Print checks, put them in an envelope, mail them out. Fine. So we do a lot of take this data, spit it on a PDF page, and then throw it at a printer. Right? That's kind of what I handle. My boss, new boss, hasn't been there a year yet. He's bringing in a new piece of software that does some shenanigans with that kind of crap, right? Can read PDFs and do bullshit with them, changing shit around and replacing images and all that kind of crap. Fine. The documentation for this is non-existent. Doesn't exist. The training data, the training documentation are videos of some guy in his 60s recording his screen and not editing out his mistakes, by the way. Program fails. Oh, I wonder why that happened. And then you see him trying to debug this thing in the video. It's like, this is not a stream. You can edit this. You know how to edit? And then the only like hint of documentation they have is in the UI for the program. Little like hover things in the UI. Little question mark things. You hover over it and it tells you what that little thing does. No, I can't search that. I can't discover that option here. It's something I found out later. We didn't buy the license for the UI. Oh, but you just need to write the ini files. With what documentation? Whose asshole am I pulling it out of? Ah! He's getting that license eventually, but like, what the hell? I'm not watching videos. Stop it. Give me documentation to read and control F in. Worst part about software, yeah, is not finding documentation or finding old, incorrect documentation is the fucking worst. Oh my God. It's so terrible. It's frustrating. So frustrating. In the language I work with, my code is the documentation, by the way. That's how everyone else in the past did their code at work was, yeah, sure, just read the code. The code's PLB. It's worse COBOL. It's so bad. I hate it. It's so bad. And I've got to work on that shit. We are working on replacing all that with Go. It's a long road, though. We just started this journey, so it's going to be a long fucking road. Yeah. I was looking at, so back to this. So I want to be able to re-encode stuff and make homebrew. And I figure, okay, the easiest thing to do on it is just put up an image and play some audio. I still have to have a lot of pieces in place, but this is what I want to basically have. Hang on. Have as the demo.
The missile knows where it is at all times.
This right here.
It knows this because it knows where it isn't.
I've already got the
subtracting where it is from where it isn't.
The graphics for it.
From where it is, whichever is greater.
Whichever is greater.
It contains a difference or deviation. The guidance.
So yeah, I want that on this,
uses
'cause I think it'll be
DDA
funny.
to generate corrective commands to drive the missile from a position where it is.
I've already got some other
to a
meme shit,
position where it isn't.
demos.
And
So
arriving at a
why not
position
more?
where
Let's
it
go.
isn't, It now is.
the 12-year-old.
Consequently, the position where it is now the position that it wasn't.
12
And it
years.
follows that the position that it was is now the position that it isn't.
The missile knows where the
event
Rockwell
the
retro
position that it is
encapsulator
in
is.
not the position that it wasn't. The system has acquired a variation.
Yeah, but yeah. So I want that on a tape because I think it'd be funny. It'd be funny to have the first homebrew a meme. Where's another one? So I've got this. This one here. A. This is one I use to flesh out some other image utilities that I have. Getting the image encoded in the way it needed to be for this. It's encoded like that. Makes this type of training videos. This is like the most documented, right? What is this one? The missile is EP.
The missile is very tired.
Very
He
tired.
Is eepy.
He is
the
eepy.
missile has had a very long day of splashing bandits and wants to take just a small sleep. He EB and Neebies to sleepy. Mibsile sleepy and need bed.
Yeah. But yeah. I've also got a brainfuck interpreter somewhere. Excuse me, and compiler on the NES. That's this one here. Excuse me, Famicom, because it needs the keyboard. That's this guy here. Do I have any other? I don't think I have. Oh, I've got oh yeah, I got the DVD screensaver. I got this one too. This one. But this stuff was fun to do. Yeah, and a lot of the work I've done is reverse engineering the study box and figuring out how that works and what makes it tick. Yeah, but anyway, just before you guys came in, I was gonna go get some food, so I apologize for ending as soon as you get here. I'm sorry. This is Pony. How you doing? But we're gonna see if somebody else is live. We're gonna go say hi to somebody. So don't go anywhere quite yet. Yeah, I'll be back on Friday, doing something. Probably more of this, honestly. Good chance it'll be more of this. I might try to old school music bits. All right. Most important part, the raid. Yeah. I might try to clean this up a little bit over the week, so we can get a little further on the weekend. Thank you for the follow, appreciate that. I don't know. We'll see. All right, let's see who is doing something. Let's go with a snake again. Why not? Twitch and your damn commercials. At least load the damn thing. Come on, Twitch. But, yeah. Please come with me to say hi. I would appreciate it. I'm waiting until this commercial to end before I hit anything. Come on, commercial. Come on. 15 seconds. It's almost there. But, yeah. Join Discord if you haven't already. I'm on there. I rant about work all the time. I don't know. I do a lot of coding, so yeah, come say hi. Yeah, you guys have a good night. I will see you next time. Bye.